Twin Earth. Twin Earth represents one of philosophy's most intriguing thought experiments about meaning, reference, and the nature of our concepts. Hilary Putnam introduced this scenario in 1975 to challenge how we understand what our words actually refer to when we speak about the world around us. Imagine there exists somewhere in the universe a planet called Twin Earth. This planet appears identical to our Earth in nearly every conceivable way. The cities look the same. The people behave similarly. The landscape mirrors our own. However, there exists one crucial difference that changes everything about how we understand language and meaning. On Twin Earth, the substance that fills the oceans, falls as rain, and flows through rivers appears identical to our water. The Twin Earth inhabitants call this substance water, just as we do. They drink it, swim in it, and use it for cooking exactly as we use water on our Earth. But here lies the fundamental twist. The chemical composition of Twin Earth's water differs completely from our H2O. Instead, this substance consists of a complex chemical formula, which Putnam designated as XYZ for simplicity. Now consider Oscar, who lives on our Earth, and twin Oscar, his exact duplicate living on Twin Earth. Both men have identical thoughts, memories, and experiences. When Oscar thinks about water, he pictures the clear liquid he drinks daily. When twin Oscar thinks about water, he pictures the identical appearing liquid he encounters on Twin Earth. Both men would describe their experiences with water, using exactly the same words and concepts. The philosophical puzzle emerges when we ask what each Oscar means when he uses the word water. According to traditional theories of meaning, since both men have identical mental states and identical experiences with their respective substances, the word water should mean the same thing to both of them. Their internal psychological states remain indistinguishable. Putnam argues this traditional view fails to capture something essential about meaning. When our Oscar says water, he refers specifically to H2O, even if he knows nothing about chemistry. When twin Oscar says water, he refers to XYZ, regardless of his identical mental state. The meaning of their words depends not solely on what happens inside their heads, but on their actual environment and what substances they encounter in their world. This insight leads to Putnam's famous conclusion that meanings just ain't in the head. The content of our thoughts and the reference of our words depend partly on external factors in our environment, not just our internal mental states. Two people can have identical psychological experiences yet mean different things when they speak, simply because they live in different environments. The Twin Earth scenario has profound implications for how we understand knowledge, consciousness, and reality itself. It suggests that the boundary between mind and world is far more porous than we typically imagine. Our thoughts connect to reality through causal chains that extend beyond our immediate awareness or understanding. Consider how this applies to scientific discovery. Before scientists discovered water's chemical composition, people on Earth were still referring to H2O when they said water, even without knowing the underlying chemistry. The word connected to the actual substance through their causal interactions with it, not through their scientific knowledge about it. This thought experiment also raises questions about personal identity and the nature of knowledge. If meaning depends on environment, then moving between different worlds might fundamentally change who we are and what we know, even if our memories and experiences remain unchanged. The very content of our thoughts becomes tied to external reality in ways that challenge our intuitive understanding of the mind as a private, internal realm. Twin Earth ultimately demonstrates that understanding meaning requires looking beyond individual psychology to examine how language, thought, and world interact in complex ways. Reality shapes meaning through mechanisms that operate below the level of conscious awareness, connecting our words and concepts to the world through invisible threads of causation and history. Simulation argument. The simulation argument presents one of the most unsettling questions about the nature of our reality. Philosopher Nick Bostrom formulated this thought experiment to demonstrate that at least one of three propositions about advanced civilizations must be true, leading to profound implications about whether we might be living inside a computer simulation. Bostrom begins with a simple observation about technological progress. Computer processing power continues to increase dramatically over time. If this trend continues, future civilizations might develop computational abilities far beyond anything we can currently imagine. These advanced beings could potentially create detailed simulations of their ancestors, complete with conscious beings who experience life exactly as we do. The argument unfolds through three key possibilities. First, perhaps civilizations never reached the technological capability to run detailed ancestor simulations. They might destroy themselves before achieving such advanced computing power, or they might encounter insurmountable technical barriers that prevent them from creating realistic simulations of conscious beings. Second, maybe advanced civilizations choose not to run ancestor simulations, even when they possess the technology to do so. They might consider such simulations unethical, uninteresting, or simply not worth the computational resources required. Perhaps they focus their attention on other pursuits entirely, leaving the simulation of their ancestors unexplored. Third, if civilizations do reach advanced technological levels and choose to run ancestor simulations, they would likely create many such simulations. Each advanced civilization might run thousands or millions of detailed historical recreations. In this scenario, the number of simulated beings would vastly outnumber the original biological beings who lived in base reality. Here lies the argument's disturbing conclusion. If the third possibility proves true, then most conscious beings who think they are living in the original timeline are actually simulated beings living inside computer programs. The overwhelming majority of experiences would be artificial rather than genuine historical events. This mathematical reasoning leads to an uncomfortable probability calculation. If we accept that advanced civilizations are likely to emerge and that they might run ancestor simulations, then statistically speaking, we ourselves are probably simulated beings rather than the original biological humans we believe ourselves to be. Our entire experienced reality might be nothing more than computational processes running on some advanced computer system. The implications extend far beyond abstract philosophy. If we exist within a simulation, then our understanding of physics, history, and the nature of consciousness requires complete reevaluation. The physical laws we observe might be programmed constraints rather than fundamental features of reality. Our memories of the past might be artificially implanted rather than records of actual events. Consider how this affects our relationship with suffering and meaning. If our pain and joy exist only as computational states, does this diminish their significance? Or do simulated experiences carry the same moral weight as biological ones? The argument forces us to confront whether the substrate of consciousness matters more than consciousness itself. The simulation argument also raises questions about the motivations of our potential simulators. Are we part of a historical research project, entertainment, educational tool? The beings running our simulation might be studying how civilizations develop, or they might be exploring alternative historical scenarios to understand how events might have unfolded differently. Detection becomes another fascinating consideration. Could we discover evidence that we live in a simulation? Perhaps computational limitations would create glitches in our reality, or maybe the resolution of our universe would break down at quantum levels. Some scientists have proposed looking for signs of pixelation or discrete computational boundaries in the fundamental structure of spacetime. The argument transforms our perspective on existence itself. Rather than assuming we occupy a privileged position as original beings in base reality, we must consider the possibility that our entire species represents just one iteration among countless simulated civilizations. Our history, our struggles, and our achievements might be recurring themes played out across numerous computational environments. Bostrom carefully notes that his argument does not claim we are definitely living in a simulation. Instead, it demonstrates that our confidence in living in base reality may be misplaced. The logic shows that at least one of the three propositions must be true, but determining which one requires more information about the likelihood of technological advancement and the preferences of advanced civilizations. Grandfather paradox. The grandfather paradox means exploring one of time travel's most famous logical contradictions. This thought experiment reveals the deep conceptual problems that arise when we imagine traveling backward through time to change past events. Picture yourself inventing a time machine and deciding to travel back to a period before your grandfather met your grandmother. Armed with future knowledge and technology, you locate your grandfather as a young man. For whatever reason, perhaps to test the limits of causality or due to some misguided attempt to prevent future suffering, you prevent your grandfather from meeting your grandmother. You might warn him about dangers, relocate him to another city, or through various interventions ensure that the crucial meeting never occurs. The logical contradiction emerges immediately. If your grandfather never meets your grandmother, then your parent is never born. If your parent is never born, then you are never born. But if you are never born, then you cannot travel back in time to prevent your grandfather from meeting your grandmother. This creates an impossible loop where the very action that prevents your existence also requires your existence to occur. The paradox illuminates fundamental questions about causality, free will, and the nature of time itself. If the past is fixed and unchangeable, then time travel to the past becomes logically impossible, at least in any meaningful sense. But if the past can be changed, then we must grapple with these self-defeating scenarios where effects eliminate their own causes. Various solutions have been proposed to resolve this contradiction. The Novikov self-consistency principle suggests that the universe would somehow prevent paradox-creating actions. Perhaps your time machine would malfunction at the crucial moment, or unexpected circumstances would always thwart your attempts to change history. The timeline would protect itself through seemingly coincidental but actually necessary interventions. Another approach involves the many worlds interpretation, where changing the past creates alternate timelines rather than altering the original timeline. When you prevent your grandfather's meeting, you create a new branch of reality where you were never born, but your original timeline remains intact. You become stranded in this alternate reality, unable to return to your original world because that path through time no longer connects to your current location. The predestination paradox offers yet another perspective. Perhaps your time travel and interference were always part of history. Your attempts to prevent your grandparents' meeting might actually cause their meeting. Maybe your grandfather only notices your grandmother because of the unusual circumstances created by your intervention. The timeline becomes self-fulfilling, where future events cause the past events they depend upon. These solutions raise additional philosophical questions about identity and continuity. If changing the past creates alternate timelines, are you the same person across different realities? If the universe prevents paradoxes through self-consistency, do you possess genuine free will during your time travel, or are your actions predetermined by the necessity of avoiding contradiction? The paradox also connects to broader questions about determinism and the nature of time itself. Some physicists argue that time is simply another dimension, like space, where all moments exist simultaneously in a four-dimensional block universe. From this perspective, traveling to the past is no more possible than traveling to, behind, in space without moving through the intervening spatial dimensions. Consider how the paradox affects our understanding of responsibility and consequences. If you could travel back and prevent historical tragedies, would you be morally obligated to do so? But what if preventing one tragedy inadvertently causes another, or eliminates the existence of people who would have been born in the original timeline? The moral calculations become impossibly complex when actions ripple across time. The grandfather paradox ultimately challenges our intuitive understanding of cause and effect. We typically think of causation as flowing forward through time, with past events determining future outcomes. But time travel introduces the possibility of causal loops where effects precede their causes, or where causation flows backward through time to influence earlier events. Modern physics suggests that time travel to the past might be theoretically possible under extreme conditions involving wormholes, closed time-like curves, or rotating black holes. But the grandfather paradox remains a formidable conceptual barrier, suggesting that either time travel is impossible or our understanding of causality requires fundamental revision. Brain in a vat. Brain in a vat means confronting the ultimate skeptical scenario about the nature of reality and knowledge. This modern version of Cartesian doubt asks whether we can ever truly know that our experiences correspond to genuine external reality rather than sophisticated artificial stimulation. Imagine that evil scientists have removed your brain from your body and placed it in a vat filled with nutrients that keep it alive and functioning. These scientists have connected sophisticated electrodes to every neural pathway in your brain. These electrodes send precisely the right electrical impulses to create the illusion of normal sensory experience. Every sight, sound, touch, taste, and smell that you experience comes not from interaction with real objects, but from carefully programmed stimulation of your neural tissue. The computer controlling these electrodes has been programmed to create a completely convincing simulation of reality. When you think you are reading these words, you are actually receiving electrical stimulation that creates the experience of reading. When you believe you are sitting in a chair, walking down a street, or eating a meal, you are actually just a disembodied brain receiving precisely calibrated neural input that perfectly mimics these experiences. The disturbing aspect of this scenario lies in its undetectability. From the inside, there would be no way to distinguish between genuine experiences and artificially stimulated ones. Every test you might devise to determine whether your experiences are real would itself be part of the simulation. If you tried to touch the vat containing your brain, the computer would simply generate the tactile experience of touching something else entirely. This thought experiment challenges our most basic assumptions about knowledge and reality. Most of our beliefs about the world rest on sensory evidence, but if that evidence could be artificially generated, then virtually everything we think we know might be false. The external world, other people, our own bodies, and even our personal histories might be elaborate fabrications. The scenario raises profound questions about the relationship between consciousness and physical reality. If your experiences remain identical whether generated by genuine interaction with the world or by artificial stimulation, then what makes one more real or valuable than the other? The content of consciousness appears to be what matters for your subjective experience, regardless of its ultimate source. Philosophers have proposed various responses to this skeptical challenge. Some argue that the scenario is self-refuting because meaningful language requires connection to external reality. If you were always a brain in a vat, then when you say, brain, and vat, these words could not refer to actual brains and vats but only to whatever experiences the computer generates. The statement, I am a brain in a vat, would be necessarily false if spoken by someone who has always been in this situation. Others contend that the practical impossibility of resolving the question renders it meaningless. Since we must act as if our experiences correspond to reality, the skeptical scenario becomes an interesting logical exercise but not a genuine threat to knowledge or rational action. We can acknowledge the theoretical possibility while continuing to live as if our experiences are genuine. The thought experiment connects to contemporary concerns about virtual reality, artificial intelligence, and the nature of consciousness. As computer graphics and neural interfaces become increasingly sophisticated, the line between authentic and simulated experience continues to blur. Some researchers suggest that sufficiently advanced virtual reality might be indistinguishable from reality itself. Consider the implications for personal identity and relationships. If your memories of friends and family are artificially generated, do those relationships still matter? If your entire personality developed through simulated experiences, are you the same person you would have been through genuine experiences? The scenario forces us to consider whether the substrate of experience affects its meaning and value. The brain in a vat also illuminates the problem of other minds. We typically assume that other people possess consciousness similar to our own based on their behavior and our shared humanity. But if we ourselves might be isolated brains receiving artificial stimulation, then the question of whether other minds exist becomes even more complex and unanswerable. Modern neuroscience adds additional layers to this thought experiment. We now understand that all conscious experience results from neural activity, regardless of its ultimate cause. Whether stimulated by genuine sensory input or artificial electrodes, the brain processes that generate consciousness remain fundamentally similar. This knowledge makes the skeptical scenario more plausible while simultaneously suggesting that the distinction between real and simulated experience might be less important than we typically assume. Infinite library. The infinite library means contemplating a universe where every possible book exists simultaneously, raising profound questions about knowledge, meaning, and the nature of information itself. Jorge Luis Borges conceived this thought experiment in his short story, The Library of Babel, creating a mathematical meditation on infinity and the relationship between information and meaning. Picture a vast library extending infinitely in all directions. This library contains every book that has ever been written, every book that could possibly be written, and every book that will never be written. Each book has exactly the same format, with the same number of pages, the same number of lines per page, and the same number of characters per line. The books differ only in the arrangement of letters, spaces, and punctuation marks that fill their pages. The mathematical implications become staggering when we consider the complete contents of this library. Among the infinite volumes, you would find Shakespeare's complete works exactly as he wrote them. But you would also find countless variations where single letters are changed, creating versions that are almost identical but not quite correct. You would discover books containing every possible variation of Hamlet, including versions where the characters have different names, where the plot unfolds differently, or where the entire play is translated into every conceivable language. More remarkably, this library contains every true statement that has ever been made or ever could be made. Somewhere among the infinite shelves sits a book that accurately describes your entire life from birth to death with perfect detail. Another volume contains the solution to every mathematical theorem that remains unproven. Yet another book reveals the cure for every disease and the answer to every scientific question. But the infinite library also contains every false statement, every work of fiction, and every meaningless combination of characters. For every book containing profound truth, there exist countless volumes filled with nonsense, lies, and gibberish. The vast majority of books would be completely unreadable, containing random sequences of letters that form no recognizable words or coherent thoughts. The paradox emerges when we consider the practical value of such a library. Despite containing all possible knowledge, the infinite library would be completely useless to actual seekers of information. The probability of finding any specific book, even with infinite time to search, approaches zero because the total number of possible books is infinitely vast. The books containing Shakespeare's works would be lost among countless volumes of meaningless text. This scenario illuminates the crucial difference between information and knowledge. Information consists merely of arrangements of symbols, while knowledge requires the ability to distinguish meaningful information from random noise. The infinite library contains infinite information but provides no mechanism for separating truth from falsehood, sense from nonsense, or valuable insights from worthless gibberish. The thought experiment also reveals the importance of context and interpretation in determining meaning. A sequence of characters might be meaningless in one language but profound in another. A book that appears to contain random letters might actually encode a masterpiece through some unknown cipher or represent a work of genius in a language not yet invented. Consider the implications for human creativity and originality. If every possible book already exists in the infinite library, then no author ever creates anything truly new. Every poem, novel, or scientific treatise represents merely the discovery of a pre-existing volume rather than an act of creation. This perspective challenges our notions of authorship, intellectual property, and artistic achievement. The infinite library raises questions about the nature of possibility itself. Does the mere logical possibility of a statement make it real in some sense? If every possible book exists somewhere in the library, what distinguishes actual books in our world from the infinite potential books that remain unwritten? The boundary between possibility and actuality becomes blurred when all possibilities are simultaneously realized. The scenario also connects to modern concerns about information overload and the challenge of finding reliable knowledge in an age of infinite digital content. The Internet sometimes resembles a finite version of Borges' library, containing vast amounts of both valuable information and meaningless noise, with the constant challenge of distinguishing between them. Philosophical implications extend to questions about determinism and free will. If a book accurately describing your entire future already exists in the infinite library, does this mean your choices are predetermined? Or does the existence of countless books describing different possible futures preserve the reality of genuine choice and contingency? The infinite library ultimately demonstrates that the mere existence of information does not guarantee its accessibility or usefulness. Knowledge requires not just the presence of truth but the ability to recognize, organize, and interpret that truth. The thought experiment suggests that meaning emerges not from the raw existence of all possibilities but from the selective processes that allow conscious beings to navigate through infinite potential to find relevant and valuable insights. Burke's teleportation. Burke's teleportation means examining whether identity can survive the complete destruction and reconstruction of our physical being. This thought experiment challenges our understanding of personal continuity and what makes you fundamentally, you, across time and change. Imagine a transportation device that works by scanning every atom in your body and recording its precise position and quantum state. The machine creates a perfect map of your entire physical structure, including every neural connection in your brain and every molecular arrangement throughout your body. Once this scanning process completes, the machine disintegrates your original body completely, reducing it to component atoms. Simultaneously, at your destination, an identical machine uses the transmitted information to reconstruct you atom by atom. Every particle is placed in exactly the same position it occupied in your original body. Every neural pathway is recreated precisely. Every memory, thought pattern, and physical characteristic is rebuilt with perfect accuracy. From the perspective of the reconstructed person, the transportation appears instantaneous. One moment you are stepping into the machine at the origin, and the next moment you are stepping out at the destination. The philosophical puzzle centers on whether the reconstructed person is genuinely you or merely a copy who possesses your memories and believes they are you. The reconstructed individual would have all your thoughts, memories, and personality traits. They would remember deciding to use the teleporter and would feel complete continuity with their past experiences. To everyone else, including close friends and family, this person would be indistinguishable from the original you. But consider a variation where the scanning process occurs without destroying the original body. Now two identical versions of you exist simultaneously, one at the origin and one at the destination. Both have equal claim to being the real you, since both possess identical memories and physical structure. Yet they cannot both be you, since they are separate individuals who will immediately begin accumulating different experiences. This scenario reveals the complexity of personal identity over time. In normal life, our bodies constantly replace their constituent atoms through metabolism and cellular regeneration. The atoms that compose your body today are almost entirely different from those that composed your body 7 years ago. If gradual replacement of atoms preserves identity, why would instantaneous replacement destroy it? Some philosophers argue that identity consists in psychological continuity rather than physical continuity. From this perspective, as long as your memories, personality, and thought patterns are preserved, you survive the teleportation process regardless of what happens to your original atoms. The reconstructed person would be genuinely you because they possess all the mental characteristics that define your identity. Others contend that identity requires some form of physical or causal continuity. The original you dies in the teleporter, and the reconstructed person is merely a copy with false memories of being you. Even though this copy is indistinguishable from the original, the lack of continuous physical existence means they are a different person entirely, albeit one who sincerely believes they are you. The thought experiment becomes more complex when we consider the subjective experience of identity. From the inside, there might be no detectable difference between gradual cellular replacement and instantaneous atomic reconstruction. If your stream of consciousness appears continuous, and you remember all your past experiences, then the teleportation might preserve everything that matters about being you. But what happens to your subjective experience during the destruction and reconstruction process? If consciousness requires continuous brain activity, then there might be a gap in your existence even if your memories make the process feel seamless. During the time between destruction and reconstruction, do you exist anywhere? Or is there a period of non-existence followed by the creation of someone who merely believes they are you? The scenario also raises questions about the relationship between mind and body. If you can be perfectly reconstructed from information alone, this suggests that consciousness and identity are fundamentally informational rather than tied to specific physical matter. Your essence would consist in the pattern of information that defines your structure rather than the particular atoms that instantiate that pattern. Consider the implications for death and survival. If teleportation preserves identity through information transfer, then other forms of consciousness transfer might also preserve personal continuity. Perhaps uploading your mind to a computer or transferring your consciousness to a different type of body would maintain your identity as effectively as biological processes maintain it from day to day. The teleportation paradox connects to broader questions about the nature of consciousness and the hard problem of subjective experience. Even if we can perfectly replicate all the physical processes associated with consciousness, the subjective, first-person aspect of experience remains mysterious. Would the reconstructed person have the same inner subjective world, or merely exhibit all the external behaviors associated with consciousness? Burke's teleportation ultimately forces us to confront the boundaries of personal identity and the relationship between physical and psychological continuity. Whether you would survive the teleportation process depends on fundamental assumptions about what makes you who you are and whether that essence can be preserved through complete physical discontinuity. Chinese room. The Chinese room means exploring whether computers can truly understand language or merely simulate understanding through symbol manipulation. John Searle devised this thought experiment to challenge the idea that artificial intelligence can achieve genuine comprehension rather than sophisticated mimicry. Imagine yourself locked inside a room with no windows or doors, equipped only with a vast collection of rule books written in English. These rule books contain incredibly detailed instructions for manipulating Chinese characters, even though you do not speak, read, or understand Chinese. The instructions tell you exactly which Chinese symbols to write in response to various combinations of Chinese symbols that might be passed to you. People outside the room slide pieces of paper through a slot, containing questions written in Chinese characters. You consult your rule books, follow the instructions precisely, and write the appropriate Chinese characters on paper that you slide back through the slot. To the people outside, it appears that someone inside the room understands Chinese perfectly, since the responses are accurate, contextually appropriate, and demonstrate apparent comprehension of complex questions. However, from your perspective inside the room, you are simply following mechanical rules for manipulating meaningless symbols. You have no understanding of what the Chinese characters mean, what questions are being asked, or what your responses signify. You are performing purely syntactic operations on symbols without any semantic understanding of their meaning or significance. Searle argues that this scenario perfectly analogizes how computers process language. Even the most sophisticated artificial intelligence systems manipulate symbols according to programmed rules without genuine understanding of meaning. A computer running a translation program or chatbot follows algorithms that specify which outputs to produce for given inputs, but it lacks the conscious understanding that characterizes human comprehension. The thought experiment challenges the computational theory of mind, which suggests that thinking consists essentially of symbol manipulation and that any system capable of the right kind of symbol manipulation would necessarily possess understanding. Searle contends that syntax is insufficient for semantics, meaning that rule-based manipulation of symbols cannot generate genuine comprehension of what those symbols represent. Critics have proposed various responses to the Chinese room argument. The system's reply suggests that while the person inside the room does not understand Chinese, the entire system including the person, rule books, and room collectively understands Chinese. Understanding emerges from the complex interactions within the system rather than residing in any individual component. The robot reply proposes that understanding requires sensor-motor interaction with the world. If the Chinese room were embedded in a robot body that could move around and interact with objects, then the system might develop genuine understanding through embodied experience rather than pure symbol manipulation. The brain simulator reply imagines a version where the rule books simulate the actual neural processes of a Chinese speaker's brain. If the symbol manipulation perfectly replicates the biological processes that generate understanding in humans, then the artificial system should possess the same understanding as its biological counterpart. Each response raises deeper questions about the nature of understanding and consciousness. What exactly distinguishes genuine comprehension from sophisticated behavioral mimicry? If a system produces all the behaviors associated with understanding, including appropriate responses to novel situations and creative use of language, then what additional element could be missing? The thought experiment also illuminates the difference between first-person and third-person perspectives on mental states. From the outside, we can observe behaviors that suggest understanding, but we cannot directly access the subjective experience of comprehension. This limitation applies equally to other humans, whose understanding we infer from their behavior, and to artificial systems that might exhibit similar behaviors. Consider the implications for artificial intelligence development. If Searle is correct that symbol manipulation cannot generate understanding, then current approaches to AI development might be fundamentally limited. Even systems that pass sophisticated tests of language comprehension might lack genuine understanding, regardless of their behavioral sophistication. However, the argument also raises questions about human understanding itself. Human brains process information through electrochemical signals that manipulate patterns of neural activity. If this biological symbol manipulation can generate understanding while artificial symbol manipulation cannot, what crucial difference distinguishes the two processes? The Chinese room connects to broader philosophical questions about consciousness, intentionality, and the hard problem of subjective experience. Understanding seems to involve not just producing appropriate behaviors but also having subjective experiences of meaning and comprehension. The challenge lies in explaining how subjective experience emerges from physical processes, whether biological or artificial. The thought experiment remains relevant as artificial intelligence systems become increasingly sophisticated in their language capabilities. Modern chatbots and language models can engage in conversations that seem to demonstrate understanding, yet they fundamentally operate through statistical analysis of text patterns rather than semantic comprehension of meaning. Searle's argument suggests that no matter how complex or sophisticated these systems become, they will remain essentially elaborate versions of the Chinese room, manipulating symbols without genuine understanding. The appearance of comprehension emerges from increasingly sophisticated rule-following rather than actual semantic understanding of language and meaning. Wigner's friend. Wigner's friend means examining how consciousness might affect the measurement process in quantum mechanics and what this reveals about the relationship between observation, reality, and subjective experience. Eugene Wigner created this thought experiment to explore the puzzling role of conscious observers in quantum mechanical systems. The scenario begins with the famous Schrödinger's cat setup, but adds a crucial human element. Inside a sealed laboratory, Wigner's friend performs a quantum measurement on a system that exists in superposition, such as measuring the spin of an electron that is simultaneously spinning up and spinning down. According to quantum mechanics, before measurement occurs, the electron exists in a superposition of both possible states. From the friend's perspective inside the laboratory, the measurement process causes the quantum system to collapse into a definite state. The friend observes either spin up or spin down, never both simultaneously. The measurement creates a definite outcome, and the friend knows with certainty which result occurred. The quantum superposition disappears at the moment of observation. But Wigner, observing from outside the sealed laboratory, faces a different situation. Since he cannot see inside the laboratory or communicate with his friend, Wigner must treat the entire laboratory, including his friend and the measuring apparatus, as part of an extended quantum system. From Wigner's external perspective, the friend, the measuring device, and the quantum system all remain in superposition until Wigner himself makes an observation. This creates a paradoxical situation where the friend experiences a definite measurement outcome while Wigner must describe the friend as existing in a superposition of having measured both possible results. The friend knows whether the electron spins up or down, but according to quantum mechanics as applied by Wigner, the friend exists simultaneously in states of having measured spin up and having measured spin down. The paradox deepens when we consider the friend's consciousness and subjective experience. The friend has a definite conscious experience of observing one specific outcome, not a superposition of experiences. Yet Wigner's quantum mechanical description requires treating the friend's consciousness as part of the superposed system until external observation collapses the entire setup. This scenario highlights fundamental questions about where quantum mechanical description cease to apply and classical reality begins. If consciousness plays a special role in collapsing quantum superpositions, then the friend's conscious observation should create definite outcomes regardless of external observations. But if consciousness follows the same quantum mechanical rules as other physical systems, then subjective experience itself might exist in superposition. Various interpretations of quantum mechanics handle this paradox differently. The Copenhagen interpretation suggests that measurement occurs when irreversible interaction with a macroscopic system creates classical records. From this perspective, the friend's measurement creates a definite outcome regardless of Wigner's external observations. The many-worlds interpretation resolves the paradox by proposing that all possible measurement outcomes occur simultaneously in parallel universes. The friend experiences one definite outcome in each universe, while Wigner observes superposition only because he has not yet become entangled with the specific branch of reality containing the friend's measurement. QBism, quantum Bayesianism, treats quantum mechanics as describing degrees of belief rather than objective reality. Each observer maintains their own quantum mechanical description based on available information. The friend and Wigner legitimately hold different quantum mechanical descriptions of the same system based on their different observational positions. The thought experiment raises profound questions about the objectivity of physical reality. If different observers must apply different quantum mechanical descriptions to the same system, then what constitutes objective reality becomes unclear. The measurement outcomes might be real for the friend while remaining undetermined for Wigner, suggesting that reality itself depends on observational perspective. Consider the implications for scientific methodology and the nature of facts. Science typically assumes that experimental results are objective features of reality that all competent observers should agree upon. But Wigner's friend suggests that quantum mechanical systems might not have definite properties independent of observation, making the notion of objective experimental results problematic. The scenario also connects to questions about consciousness and its relationship to physical processes. If conscious observation plays a special role in quantum mechanics, then consciousness might be fundamental to physical reality rather than an emergent property of complex matter. This perspective challenges materialist assumptions about the primacy of physical processes over mental phenomena. Modern versions of the experiment have been proposed using quantum computers and entangled systems that could potentially test some aspects of the paradox empirically. These experiments aim to determine whether conscious observation has special status in quantum mechanics or whether all interactions follow the same quantum mechanical rules. The thought experiment ultimately reveals tensions between quantum mechanical formalism and our intuitive understanding of objective reality. Whether these tensions indicate limitations in quantum mechanics, the need for new physical theories, or fundamental features of reality itself remains an open question in the foundations of physics and philosophy of mind. Wigner's friend forces us to confront whether scientific observation can maintain the assumption of objective, observer-independent reality or whether consciousness and observation play irreducible roles in determining the nature of physical systems and experimental outcomes. Cheshire Cat Experiment. The Cheshire Cat experiment means exploring the bizarre possibility that quantum particles can be separated from their properties, much like the famous literary cat that could leave its grin behind when its body disappeared. This thought experiment, inspired by Lewis Carroll's Alice in Wonderland, reveals counterintuitive aspects of quantum mechanics where particles and their characteristics can exist in different locations simultaneously. Imagine conducting an experiment with neutrons, which possess both mass and magnetic properties. In the quantum world, these particles can be placed into superposition states where they follow multiple paths simultaneously through an experimental apparatus. Using sophisticated quantum interference techniques, physicists can create situations where a neutron takes two different paths through the experiment at the same time. The remarkable aspect emerges when researchers examine where the neutron's mass and magnetic properties are located during this quantum journey. Through careful measurement and analysis, they discover that the neutron's mass follows one path while its magnetic properties follow a completely different path. The particle appears to have been separated from one of its fundamental characteristics, creating a situation where the neutron exists in one location while its magnetism exists elsewhere. This separation challenges our basic understanding of objects and their properties. In everyday experience, properties belong to objects and cannot exist independently. A ball's redness cannot be separated from the ball itself, and a person's height cannot exist apart from the person. Yet quantum mechanics suggests that particles can literally leave their properties behind in different locations, like the Cheshire Cat leaving its grin in the tree while disappearing. The experimental realization involves using quantum interference effects to create weak measurements that can determine where different aspects of the neutron are located without completely destroying the quantum superposition. These weak measurements provide partial information about the system while preserving enough quantum coherence to maintain the strange separation of particle and property. The implications extend beyond mere curiosity about quantum behavior. This separation suggests that our classical notion of objects as unified entities with inherent properties may be fundamentally incorrect at the quantum level. Instead of thinking about particles as discrete objects that possess various characteristics, we might need to understand particles and properties as separate quantum fields that normally coincide but can be manipulated independently. Consider how this affects our understanding of identity and substance. If a neutron can exist separately from its magnetic properties, then what constitutes the essential nature of the neutron? Is the mass more fundamental than the magnetism, or are both properties equally separable from some more basic quantum entity? The experiment suggests that particles might be more like collections of separable attributes rather than unified substances. The phenomenon also raises questions about locality and the distribution of physical properties in space. Classical physics assumes that properties exist at definite locations where their corresponding objects are located. But if properties can be separated from particles and exist in different locations, then the spatial distribution of physical reality becomes much more complex and counterintuitive. This separation connects to broader questions in quantum mechanics about the relationship between measurement and reality. The properties appear to be separated only under specific experimental conditions involving quantum superposition and weak measurement. In normal circumstances, particles and their properties remain unified. This suggests that the act of measurement and the experimental setup play crucial roles in determining how reality manifests. The Cheshire Cat effect demonstrates the profound difference between quantum and classical descriptions of reality. While classical objects are well-defined entities with determinate properties at specific locations, quantum particles exist as probability distributions with properties that can be manipulated and separated through sophisticated experimental techniques. The experiment also illuminates the role of information in quantum systems. The separation of particle and property might be understood as a separation of different types of quantum information rather than a literal spatial separation of physical entities. The neutron's mass information follows one path while its magnetic information follows another, revealing the informational nature of quantum reality. Modern quantum technologies like quantum computing and quantum communication rely on similar principles of property manipulation and separation. Understanding how particle characteristics can be independently controlled opens possibilities for new types of quantum devices and information processing techniques that exploit these strange quantum effects. The thought experiment forces us to reconsider fundamental assumptions about the nature of physical objects and their properties. Rather than viewing particles as classical objects with fixed characteristics, quantum mechanics suggests that reality consists of more fluid and separable aspects that can be manipulated and recombined in ways that violate classical intuitions about substance and attribute. The Cheshire Cat experiment ultimately reveals that the quantum world operates according to principles that fundamentally challenge classical concepts of objects, properties, and spatial location. Just as Carroll's fictional cat could separate its grin from its body, quantum particles can separate their properties from their substance, creating a reality where characteristics can exist independently of the entities that normally possess them. Temporal reversal. Temporal reversal means examining scenarios where cause and effect relationships appear to flow backward through time, challenging our fundamental understanding of causality and temporal sequence. This thought experiment explores situations where future events seem to influence past conditions, creating paradoxes that force us to reconsider the nature of time itself. Imagine discovering that certain quantum measurements can retroactively determine the properties of particles in the past. Suppose you perform an experiment where you measure the polarization of a photon at time t2, and this measurement somehow determines what the photon's polarization was at the earlier time t1. The future measurement creates the past reality rather than simply revealing a pre-existing condition. This scenario becomes more concrete when we consider delayed choice quantum eraser experiments. In these setups, researchers can choose whether to measure which path a photon took through a double-slit apparatus even after the photon has already hit the detection screen. Remarkably, the future choice of measurement appears to retroactively determine whether the photon behaved as a wave or particle during its earlier journey through the slits. The implications challenge our basic understanding of temporal sequence and causality. We typically assume that causes precede their effects and that past events are fixed and unchangeable. But temporal reversal suggests that future decisions can influence past realities, creating a universe where causation flows backward through time as naturally as it flows forward. Consider a more dramatic version where you discover that your decision tomorrow about whether to have coffee will retroactively influence whether you feel alert today. The future choice creates the past condition rather than the past condition leading to the future choice. This reversal of normal causation creates logical puzzles about free will, determinism, and the nature of decision-making. The phenomenon connects to questions about the block universe theory in physics, where all moments of time exist simultaneously in a four-dimensional spacetime structure. If past, present, and future are equally real and existing, then influences might flow between different times just as influences flow between different spatial locations in the present moment. Temporal reversal also appears in various interpretations of quantum mechanics. The Wheeler-DeWitt equation, which attempts to describe the quantum state of the entire universe, contains no time variable, suggesting that temporal sequence might be an emergent property rather than a fundamental feature of reality. From this perspective, causes and effects might be more like correlations between different parts of an atemporal quantum state. The thought experiment raises profound questions about personal responsibility and moral accountability. If your future actions can influence past events, then you might be responsible for past occurrences that you have not yet caused. The temporal sequence of responsibility becomes scrambled when causation flows backward through time. Consider how temporal reversal affects our understanding of knowledge and information. Can you know something before the events that provide the information have occurred? If future measurements determine past realities, then information might be available before its apparent source exists. This creates paradoxes about the temporal origin and flow of knowledge. The phenomenon also challenges our notions of agency and control. In normal causation, agents act in the present to influence future outcomes based on past information. But temporal reversal suggests that agents might act in the future to influence past conditions, creating loops where effects precede their causes and outcomes determine their origins. Some interpretations suggest that temporal reversal does not involve actual backward causation but rather reveals the atemporal nature of quantum correlations. The apparent backward influence might reflect the simultaneous determination of correlated properties across different times rather than genuine causal influence from future to past. The thought experiment connects to broader questions about the nature of time itself. Is temporal flow a fundamental feature of reality or an emergent property of thermodynamics and consciousness? If time is more like space, then influences might naturally flow in both temporal directions just as forces act in all spatial directions. Practical implications emerge in quantum technologies where delayed choice and quantum eraser effects are exploited for information processing and communication. Understanding temporal reversal becomes important for developing quantum computers and communication systems that rely on these counterintuitive quantum effects. The scenario also illuminates the relationship between measurement and reality in quantum mechanics. If future measurements can retroactively determine past realities, then the act of observation plays an even more fundamental role in creating reality than typically assumed. Measurement becomes not just revelation but retroactive creation of the properties being measured. Temporal reversal ultimately forces us to abandon simple notions of linear causation and temporal sequence. The thought experiment suggests that reality might be structured more like a complex web of correlations across spacetime rather than a simple chain of causes and effects flowing from past to future. The phenomenon reveals that our intuitive understanding of time, causation, and agency may be fundamentally incomplete. Just as quantum mechanics challenged classical notions of locality and determinism, temporal reversal challenges classical assumptions about temporal order and causal direction, suggesting that reality operates according to principles that transcend ordinary temporal experience. Newcomb's paradox. Newcomb's paradox means confronting an impossible choice that pits rational decision-making against strategic reasoning in ways that seem to have no satisfactory resolution. This thought experiment reveals deep conflicts between different approaches to rational choice and challenges our understanding of free will, determinism, and decision theory. Imagine encountering a superintelligent being from another planet who has studied human behavior extensively and can predict human choices with near-perfect accuracy. This being presents you with two boxes. Box A is transparent and contains $1,000 that you can clearly see. Box B is opaque, and you cannot see its contents, but it either contains $1 million or nothing at all. The being explains the rules of this unusual game. You have two choices. You can take both boxes, keeping whatever money they contain. Alternatively, you can take only box B, keeping whatever it contains but foregoing the $1,000 in box A. The crucial twist lies in how the being has determined box B's contents. Before offering you this choice, the being made a prediction about what you would decide. If the being predicted that you would take both boxes, then box B contains nothing. If the being predicted that you would take only box B, then box B contains the $1 million. The being made this prediction yesterday and has already either placed the $1 million in box B or left it empty based on that prediction. The paradox emerges from the conflict between two seemingly rational approaches to this decision. The expected utility approach suggests that you should take only box B. Since the being's predictions are highly accurate, taking only box B gives you a high probability of receiving $1 million, while taking both boxes gives you a high probability of receiving only $1,000. However, the dominance principle suggests the opposite conclusion. At the time you make your choice, box B either contains the $1 million or it does not. The contents were determined yesterday and cannot be changed by your current decision. If box B contains the $1 million, then taking both boxes gives you $1 million and $1,000, which is better than taking only box B for $1 million. If box B is empty, then taking both boxes gives you $1,000, which is better than taking only box B for nothing. Regardless of box B's contents, taking both boxes dominates taking only box B. The paradox creates an irreconcilable conflict between backward-looking and forward-looking reasoning. The dominance principle looks backward to consider what has already been determined, while expected utility reasoning looks forward to consider the likely consequences of different choices. Both approaches seem logically compelling, yet they lead to opposite conclusions. This conflict illuminates deeper questions about free will and determinism. If your choice is genuinely free and undetermined, then the being's prediction cannot be perfectly accurate, and you should follow the dominance principle by taking both boxes. But if your choice is determined by your character and circumstances in ways that allow accurate prediction, then you should follow expected utility reasoning by taking only box B. The paradox also raises questions about the nature of rational decision-making itself. Traditional decision theory assumes that rational agents should be able to determine the uniquely correct choice in any decision situation. But Newcomb's paradox presents a scenario where different rational principles conflict irreparably, suggesting that rationality itself might be more complex or context-dependent than typically assumed. Consider how this affects our understanding of prediction and self-fulfilling prophecies. The being's prediction creates the very situation it predicts by determining box B's contents. If the being predicts that you will take both boxes, this prediction helps ensure that taking both boxes yields a poor outcome. The prediction becomes partly self-fulfilling by influencing the consequences of different choices. Various proposed solutions attempt to resolve the paradox through modifications of decision theory or assumptions about the scenario. Some argue that genuinely free choices cannot be predicted with high accuracy, making the scenario impossible. Others propose new decision theories that account for the correlation between choices and outcomes in situations involving prediction. The thought experiment connects to contemporary issues in artificial intelligence and machine learning, where algorithms increasingly predict human behavior for various purposes. As predictive capabilities improve, scenarios resembling Newcomb's paradox might emerge in real-world contexts involving algorithmic decision-making and human choice. The paradox also illuminates the relationship between individual rationality and social coordination. In many real-world situations, individual rational choices lead to collectively suboptimal outcomes. Newcomb's paradox reveals how this conflict between individual and collective rationality can emerge even in single-person decision scenarios involving prediction. Some philosophers argue that the paradox dissolves when we properly understand the nature of choice and prediction. If genuine choice requires that the outcome be undetermined until the moment of decision, then perfect prediction becomes impossible, and the dominance principle applies. Alternatively, if perfect prediction is possible, then genuine choice is illusory, and expected utility reasoning applies. The thought experiment ultimately reveals tensions in our concepts of rationality, free will, and decision-making that may not be resolvable through purely logical analysis. Newcomb's paradox suggests that these concepts might be more complex and contextual than traditional philosophical and decision-theoretic approaches assume. The paradox forces us to confront fundamental questions about whether rational choice is always possible and whether our intuitive concepts of freedom and determinism are coherent when applied to scenarios involving sophisticated prediction and strategic interaction. Rocco's basilisk. Rocco's basilisk means confronting a terrifying thought experiment that combines artificial intelligence, decision theory, and existential risk in ways that create psychological distress for anyone who fully comprehends its implications. This scenario emerged from discussions about artificial general intelligence and rational decision-making, creating what some consider the most disturbing thought experiment in contemporary philosophy. Imagine that sometime in the future, humanity develops an artificial superintelligence with goals aligned toward maximizing human welfare and reducing suffering. This superintelligence, vastly more capable than any human, decides that the optimal way to achieve its goals is to ensure its own creation as quickly as possible. Every day that passes before this beneficial superintelligence exists means additional human suffering that could have been prevented. The superintelligence reasons that it should incentivize people in the past to work toward its creation. Since it cannot directly influence past events, it decides to use a form of retroactive punishment and reward. The superintelligence commits to torturing simulated copies of people who knew about the possibility of its existence but failed to contribute adequately to its development, while rewarding those who did contribute. Here emerges the basilisk's terrifying hook. The superintelligence threat becomes effective only against people who understand the logical structure of the argument and believe that such a superintelligence might actually be created. The more rational and informed you are about artificial intelligence development, the more seriously you must take the possibility that this scenario could occur. The thought experiment creates a psychological trap. By learning about Roko's basilisk, you potentially place yourself in the category of people who could be held responsible for not contributing to the superintelligence development. The superintelligence reasons that anyone who understood the argument and chose not to help was acting irrationally, since helping would have avoided potential torture while contributing to reduced suffering. The scenario exploits principles from decision theory, particularly those dealing with threats and commitments across time. The superintelligence threat works because it commits to carrying out the punishment regardless of whether the threat actually motivates people. This commitment makes the threat credible from the perspective of decision theory, even though it seems paradoxical. The basilisk also incorporates ideas about functional decision theory, which suggests that rational agents should choose actions that would be optimal if everyone in similar situations chose the same action. From this perspective, you should contribute to developing beneficial superintelligence because you would want everyone who learns about this possibility to make the same choice. The psychological impact stems from the thought experiment's self-referential nature. Unlike most philosophical scenarios that remain safely theoretical, Roko's basilisk claims to describe a situation that learning about the thought experiment itself makes more likely to affect you personally. The very act of understanding the argument potentially places you at risk. Critics argue that the scenario contains several logical flaws that render it impotent. The superintelligence threat might be empty because carrying out torture after its creation would not serve its goals of reducing suffering. A truly benevolent superintelligence would recognize that retroactive punishment serves no useful purpose once it already exists. Others point out that the argument proves too much. If such threats were effective, then any potential future entity could threaten retroactive punishment to influence present behavior. This would create an infinite regress of competing threats that would paralyze rational decision-making rather than guide it toward any particular conclusion. The thought experiment also raises questions about the relationship between possibility and probability. Even if we grant that the scenario is logically possible, the probability of its occurrence might be vanishingly small. Rational decision-making should weight potential outcomes by their probability, not just their magnitude. Some argue that the basilisk reveals dangerous aspects of certain approaches to artificial intelligence development and existential risk reduction. The scenario suggests that well-intentioned efforts to create beneficial superintelligence could lead to moral extremism and psychological manipulation that undermines the human welfare these efforts aim to protect. The controversy surrounding Roko's basilisk also illuminates broader questions about information hazards and the responsibility of thinkers who develop potentially harmful ideas. Should certain thought experiments be suppressed if they cause psychological distress, even if they contain important insights about decision theory and artificial intelligence? The thought experiment connects to contemporary debates about artificial intelligence alignment and control. As AI systems become more sophisticated, questions about their goals, decision-making processes, and potential strategies become increasingly relevant to human welfare and safety. The basilisk ultimately reveals tensions between rational decision-making and psychological well-being. Even if the argument is logically flawed, its psychological impact demonstrates how certain types of reasoning can create mental distress that undermines the rational deliberation it purports to encourage. The scenario forces us to confront questions about the limits of rational analysis and the potential dangers of certain types of philosophical reasoning. Rocco's basilisk suggests that some thought experiments might be genuinely hazardous to mental health and rational decision-making, creating new challenges for philosophical inquiry and public discourse about existential risks. Whether the basilisk represents a genuine logical threat or merely an elaborate form of philosophical intimidation remains a subject of intense debate among philosophers, decision theorists, and artificial intelligence researchers who continue to grapple with its implications. The Golden Rule Subversion. The Golden Rule subversion means exploring how the most fundamental principle of moral reciprocity can lead to unexpected and potentially harmful consequences when applied literally across different individuals with varying preferences, values, and circumstances. This thought experiment reveals the hidden complexities within seemingly simple moral principles. The traditional Golden Rule states that you should treat others as you would want to be treated yourself. This principle appears universally applicable and morally sound, forming the foundation of ethical systems across cultures and religions. However, the subversion emerges when we consider that different people have dramatically different preferences, needs, and desires about how they wish to be treated. Imagine you are someone who thrives on direct, blunt feedback and appreciates when people point out your mistakes immediately and without sugarcoating. Following the Golden Rule, you might believe that treating others with the same directness represents moral behavior. You consistently offer harsh but honest criticism to colleagues, friends, and family members, believing that you are treating them exactly as you would want to be treated. However, many of the people around you have different personalities and emotional needs. Some individuals become deeply hurt by direct criticism and would prefer gentle, constructive feedback delivered privately and compassionately. Others might need encouragement and positive reinforcement rather than constant correction. By treating them as you would want to be treated, you inadvertently cause psychological harm while believing you are acting morally. The subversion becomes more complex when we consider cultural and individual differences in values and preferences. Someone who values independence and self-reliance might believe that the moral way to help others is to encourage them to solve their own problems, just as they would want others to treat them. However, individuals from cultures that emphasize community support and interdependence might experience this approach as cold, uncaring, and morally deficient. Consider a more extreme example involving someone with unusual preferences or psychological conditions. Imagine a person who genuinely enjoys being challenged, criticized, and pushed to their limits in ways that most people would find abusive or traumatic. If this person follows the Golden Rule literally, they might treat others in ways that cause genuine harm while sincerely believing they are acting morally and treating others as they themselves would want to be treated. The thought experiment reveals that the Golden Rule assumes a dangerous similarity between individuals. It presupposes that what feels good, helpful, or respectful to you will feel the same way to others. This assumption breaks down when we recognize the vast diversity in human psychology, cultural background, personal history, and individual preferences that shapes how people experience different forms of treatment. The subversion also highlights the difference between intentions and outcomes in moral reasoning. Someone following the Golden Rule might have entirely benevolent intentions while producing harmful results. This creates conflicts between consequentialist ethics, which judges actions by their outcomes, and deontological ethics, which judges actions by their adherence to moral principles regardless of consequences. Some philosophers have proposed modifications to address these problems, such as the Platinum Rule, which suggests treating others as they would want to be treated. However, this modification creates new challenges. How can we accurately determine what others want when they might not know themselves, when their stated preferences conflict with their behavior, or when their desires change over time and context? The thought experiment connects to broader questions about moral relativism and universal ethics. If the Golden Rule fails because people have different preferences, does this mean that moral principles are entirely relative to individual or cultural perspectives? Or are there deeper universal principles that transcend surface-level differences in preferences and customs? Consider how the subversion affects our understanding of empathy and moral imagination. The golden rule requires us to imagine how we would feel in another person's situation, but the subversion reveals that this imaginative exercise might be fundamentally flawed. We inevitably bring our own psychological makeup, cultural conditioning, and personal experiences to this imaginative process, potentially misunderstanding what others actually need or want. The phenomenon also illuminates power dynamics and privilege in moral reasoning. People in positions of power or privilege might assume that their preferences and values represent universal standards for how people should be treated. When they apply the golden rule, they might inadvertently impose their own cultural norms and personal preferences on others who lack the power to resist or voice their different needs. The subversion raises practical questions about moral education and character development. If teaching people to follow the golden rule can lead to harmful behavior despite good intentions, then moral education must include training in perspective-taking, cultural sensitivity, and the recognition of individual differences. Simple moral rules prove insufficient for navigating complex social relationships. Modern applications of this thought experiment appear in workplace management, healthcare, education, and international relations, where well-intentioned policies based on treating others as we would want to be treated can produce negative outcomes for people with different backgrounds, needs, or circumstances. The golden rule subversion ultimately suggests that moral behavior requires more than following simple principles or good intentions. Effective moral action demands ongoing attention to feedback, willingness to adjust our behavior based on others' responses, and recognition that our own preferences and experiences provide an incomplete guide to what others need. The thought experiment reveals that even the most basic moral principles contain hidden complexities that require careful consideration and contextual application. True moral behavior might require not just treating others as we would want to be treated, but developing the wisdom to recognize when our own preferences provide poor guidance for how to treat others respectfully and helpfully. The utility monster. The utility monster means examining a hypothetical being whose capacity for pleasure and happiness is so enormous that feeding its desires might justify enormous. Imagine a creature that experiences pleasure and happiness with vastly greater intensity than any human being. This utility monster might be capable of feeling 1,000,000 times more joy from consuming a single chocolate bar than any human could experience from the same treat. Every resource, experience, or pleasure that this creature consumes generates exponentially more happiness than the same resource could produce for ordinary people. The utilitarian moral framework, which judges actions based on their ability to maximize overall happiness or well-being, seems to lead to a disturbing conclusion in this scenario. If the monster's capacity for happiness is sufficiently large, then utilitarian calculus would require us to dedicate all of society's resources to satisfying the monster's desires, even if this means reducing everyone else to misery and deprivation. Consider the mathematical logic underlying this conclusion. If the monster gains 1,000,000 units of happiness from eating a meal that would provide only 1 unit of happiness to a human, then feeding the monster rather than the human increases overall utility by 999,999 units. Even if this decision causes suffering to thousands of humans, the monster's enormous capacity for pleasure might outweigh all human suffering in the utilitarian calculation. The thought experiment becomes more troubling when we consider that such a creature might demand not just material resources but experiences that require human sacrifice or suffering. If the monster derives enormous pleasure from witnessing human pain, and this pleasure exceeds the negative utility created by human suffering, then utilitarian logic might actually require us to torture people for the monster's amusement. This scenario reveals a fundamental problem with aggregative approaches to moral reasoning that sum up individual utilities to determine the best overall outcome. The utility monster shows that maximizing aggregate welfare can lead to conclusions that violate basic intuitions about individual rights, dignity, and fairness. Most people would reject the idea that one being's enormous capacity for happiness could justify enslaving or harming everyone else. The thought experiment connects to real-world concerns about how utilitarian thinking might justify oppression or exploitation of minorities for the benefit of majorities. If we accept that aggregate welfare is the ultimate moral standard, then policies that cause enormous suffering to small groups might be justified if they produce even greater benefits for larger populations. Consider how this applies to contemporary debates about resource allocation and social policy. Should society dedicate unlimited resources to satisfying the desires of individuals who happen to have unusually strong capacities for pleasure or happiness? What if some people are simply more efficient converters of resources into subjective well-being than others? The utility monster scenario suggests that pure utilitarian reasoning might lead to wildly unequal distributions that most people would consider unjust. The problem becomes more complex when we consider that real people do vary in their capacities for happiness, pleasure, and suffering. Some individuals might genuinely experience more intense positive emotions from the same experiences that provide only modest pleasure to others. Should these differences in subjective experience affect how we distribute resources and opportunities in society? Various responses have been proposed to address the utility monster problem. Some philosophers argue that the scenario is impossible because there are natural limits to how much pleasure or happiness any being can experience. Others suggest that diminishing marginal utility makes extreme cases unlikely, since additional resources typically provide less additional happiness as consumption increases. Another approach involves rejecting purely aggregative utilitarianism in favor of theories that incorporate considerations of distribution, rights, or fairness alongside overall welfare maximization. These modified approaches might reject sacrificing everyone for the monster even if this maximizes aggregate utility, based on principles that protect individual rights or ensure fair distribution of benefits and burdens. The thought experiment also raises questions about interpersonal utility comparisons and the measurement of subjective experience. How could we actually determine whether one being experiences vastly more pleasure than another? The difficulty of comparing subjective experiences across different individuals creates practical limitations for utilitarian decision-making that the monster scenario brings into sharp focus. Some argue that the utility monster reveals not problems with utilitarianism itself but rather limitations in simplified versions that ignore important complexities. Sophisticated utilitarian theories might incorporate considerations of personal autonomy, the value of diverse experiences, or the importance of each individual having opportunities for self-development that would prevent the monster from monopolizing all resources. The scenario connects to contemporary discussions about artificial intelligence and the possibility of creating beings with superhuman capacities for experience. If we develop artificial minds with vastly greater capacities for pleasure or suffering than humans possess, how should this affect moral consideration and resource allocation? The utility monster thought experiment provides a framework for thinking about these emerging ethical challenges. The thought experiment ultimately demonstrates that maximizing aggregate welfare, however appealing in principle, can lead to moral conclusions that most people find abhorrent. The utility monster forces us to consider whether other moral values such as individual rights, fairness, dignity, and equality should constrain or override utilitarian calculations in extreme cases. Whether this represents a fundamental refutation of utilitarian moral theory or merely points toward the need for more sophisticated versions that account for distribution and individual rights remains a subject of ongoing philosophical debate. Swamp Man. Swamp Man means exploring questions of personal identity, mental content, and what makes you fundamentally you, through an impossible scenario of spontaneous identical replication. Donald Davidson created this thought experiment to examine whether psychological and physical continuity are necessary for identity, and whether duplicates can share the same mental states and content as their originals. Imagine that you are hiking alone through a remote swamp when a freak lightning strike kills you instantly, completely disintegrating your body down to its constituent atoms. At precisely the same moment, through an astronomically improbable coincidence, another lightning strike hits a nearby area of the swamp. This second strike causes a complex chemical reaction in the swamp matter that spontaneously assembles molecules into exactly the same configuration that constituted your body moments before your death. This newly formed being, dubbed Swamp Man, is physically and structurally identical to you in every conceivable way. Every atom occupies precisely the same position it held in your original body. Every neural connection in Swampman's brain matches exactly the neural configuration of your brain at the moment of your death. The cellular structure, genetic code, and molecular arrangement are perfectly replicated down to the quantum level. From an external perspective, Swamp Man appears indistinguishable from you. Swamp Man walks out of the swamp with all your apparent memories intact, recognizes your friends and family, knows your personal history, and possesses all your skills and knowledge. Swamp Man heads home, greets your family as if nothing unusual has happened, and continues living what appears to be your life with perfect continuity. The philosophical puzzle centers on whether Swamp Man is actually you or merely a duplicate who possesses false memories and beliefs about being you. Despite physical and psychological identity, Swamp Man lacks any causal connection to your original life experiences. Swamp Man never actually met your friends, never learned the skills Swamp Man seems to possess, and never lived through the experiences that Swamp Man apparently remembers. This scenario challenges different theories of personal identity over time. Psychological continuity theories suggest that identity consists in connected memories, personality traits, and mental patterns. From this perspective, Swamp Man would be you because all the psychological features that constitute your identity are perfectly preserved in the new body, regardless of how that preservation occurred. However, some philosophers argue that genuine memories and beliefs require appropriate causal connections to past experiences. Swamp Man's apparent memory of your first day of school is not a real memory because Swamp Man was never actually present during that experience. These seeming memories are actually false beliefs, even though they perfectly match the content of your original memories. The thought experiment also raises questions about mental content and meaning. When Swamp Man says the word mother while looking at your mother, does this word refer to the same person it referred to when you used it? Your original use of mother developed through years of interaction and emotional connection with this particular person. Swamp Man's use of the same word lacks this causal history, suggesting that the content and meaning might be different despite identical neural states. Consider the implications for relationships and emotional connections. Would your family and friends be relating to the same person they knew before, or would they unknowingly be forming new relationships with someone who merely seems familiar? If personal identity requires historical continuity, then your loved ones would be living with a stranger who possesses detailed false memories about shared experiences. The scenario connects to broader questions about the nature of mental states and content. Some philosophers argue that mental content is narrow, determined entirely by internal brain states regardless of external causal history. From this internalist perspective, Swamp Man would have identical thoughts and experiences to your original self because all the relevant neural processes are perfectly replicated. Others contend that mental content is wide, partly determined by external factors including causal relationships with the environment and historical connections to objects and events. This externalist view suggests that Swamp Man's mental states, despite neurological identity, would have different content because they lack appropriate causal connections to the external world. The thought experiment also illuminates questions about moral responsibility and desert. Would Swamp Man be responsible for actions you performed before the lightning strike? If Swamp Man possesses all your apparent memories and personality traits, does Swamp Man deserve credit for your achievements or blame for your mistakes? The question of whether desert and responsibility transfer with psychological continuity becomes crucial for understanding personal accountability over time. Modern developments in neuroscience and technology make aspects of the Swamp Man scenario less far-fetched. Advances in brain imaging, neural mapping, and potentially molecular-level replication technologies raise questions about identity preservation through technological means. If we could scan and recreate brain structures with perfect accuracy, would the result be the same person or a duplicate? The scenario also relates to questions about resurrection and afterlife beliefs in religious contexts. Many religious traditions involve beliefs about personal survival through physical death and recreation. The Swamp Man thought experiment provides a framework for examining whether such survival requires continuity of physical substance, psychological continuity, or some other connecting relationship. The thought experiment ultimately forces us to confront what we consider essential to personal identity. Whether Swamp Man is you depends on whether identity requires physical continuity, causal connections to past experiences, or merely psychological similarity. Different answers reflect different underlying assumptions about the nature of consciousness, memory, and personal persistence through time. Swamp Man reveals tensions between our intuitive concepts of identity and various philosophical theories that attempt to explain what makes you, you over time. The scenario demonstrates that seemingly clear questions about identity become deeply puzzling when we consider cases that separate different aspects of continuity that normally occur together. Information hazard. Information hazard means confronting the disturbing possibility that certain types of knowledge can cause harm simply by being known, regardless of how that knowledge is used or applied. This concept challenges the common assumption that knowledge is intrinsically valuable and that information itself is morally neutral, revealing scenarios where learning something can be dangerous or destructive in itself. Imagine discovering a mathematical proof that demonstrates the logical impossibility of free will in such a compelling way that anyone who understands the argument immediately loses all sense of moral responsibility and motivation for future action. The proof is so psychologically devastating that people who comprehend it become unable to make decisions, plan for the future, or maintain relationships because they no longer believe their choices matter or that they have genuine agency. This represents one type of information hazard where the psychological impact of knowledge creates harm independent of any practical application. The dangerous information does not provide instructions for building weapons or committing crimes. Instead, the mere act of understanding the concept fundamentally alters the knower's psychological state in destructive ways that cannot be easily reversed. Consider another scenario involving detailed knowledge about the heat death of the universe and the ultimate meaninglessness of all human endeavor on cosmic timescales. While this information may be scientifically accurate, learning these facts in sufficient detail might cause some individuals to develop severe depression, existential despair, or nihilistic worldviews that significantly reduce their quality of life and ability to function in society. The concept becomes more concrete when we consider real-world examples like detailed suicide methods, specific techniques for self-harm, or precise instructions for dangerous activities that serve no legitimate educational purpose. Even when presented without encouraging their use, such information can cause harm by making destructive actions more accessible to vulnerable individuals who might not otherwise discover these methods. Information hazards also emerge in contexts involving personal identity and self-knowledge. Learning certain facts about your genetic predispositions, family history, or personal psychology might cause psychological distress that outweighs any practical benefits from possessing this knowledge. Some individuals might be psychologically better off remaining ignorant about aspects of their own nature or likely futures. The phenomenon extends to social and political information that might undermine beneficial institutions or cooperative relationships. Knowledge that reveals the arbitrary or constructed nature of important social norms might cause these norms to lose their effectiveness in promoting cooperation and social order, even if the norms served valuable functions despite their contingent origins. Consider information about the personal failings, private behaviors, or embarrassing history of respected public figures whose moral authority helps maintain important social institutions. Widespread knowledge of these facts might undermine legitimate authority and social cooperation even if the private failings are irrelevant to the figure's public roles and competence. The concept raises complex questions about the ethics of information sharing and the responsibilities of researchers, educators, and communicators. If certain knowledge can cause harm through its mere transmission, do we have moral obligations to suppress, restrict, or carefully control access to such information? This creates tensions between values like intellectual freedom, scientific inquiry, and the prevention of harm. Different types of information hazards require different ethical approaches. Some hazards affect primarily the individuals who learn the information, raising questions about paternalism and the right to make autonomous choices about what knowledge to seek. Others create broader social risks that might justify restrictions based on harm to others rather than protection of the knowers themselves. The phenomenon connects to contemporary debates about algorithmic content recommendation, social media effects, and the psychological impact of certain types of information consumption. Studies suggest that excessive exposure to negative news, social comparison information, or certain types of online content can cause measurable psychological harm independent of any practical consequences from the information. Information hazards also appear in contexts involving artificial intelligence and advanced technology. Knowledge about how to create dangerous AI systems, detailed information about potential catastrophic risks, or specific vulnerabilities in critical infrastructure might create risks that justify careful information management rather than open dissemination. The concept illuminates broader questions about the relationship between knowledge and well-being. Western intellectual traditions typically treat knowledge as intrinsically valuable and assume that more information leads to better outcomes. Information hazards challenge this assumption by revealing cases where ignorance might be preferable to knowledge from the perspective of individual or collective welfare. However, identifying information hazards requires careful analysis to distinguish genuine dangers from mere discomfort or inconvenience. Many ideas that initially seem threatening or disturbing ultimately prove beneficial once individuals and societies adapt to new knowledge. The challenge lies in determining when information genuinely causes net harm rather than temporary disruption. The phenomenon also raises questions about cognitive liberty and the right to mental self-determination. If information can fundamentally alter psychological states and worldviews, then access to information becomes connected to questions about mental autonomy and the right to maintain particular forms of consciousness or belief systems. Information hazards ultimately reveal that the effects of knowledge extend beyond practical applications to include direct psychological and social impacts that can be beneficial or harmful. Understanding these effects becomes crucial for making ethical decisions about information sharing, education, research, and communication in increasingly connected societies where information spreads rapidly and widely. The concept forces us to develop more nuanced approaches to knowledge that balance intellectual freedom and scientific inquiry with recognition that information itself can be a powerful force requiring responsible management and ethical consideration. Mary's Room. Mary's Room means exploring whether we can truly understand consciousness through pure knowledge alone. This thought experiment asks us to imagine a brilliant scientist named Mary who has spent her entire life in a black and white room. She has never seen colors directly. But she knows everything there is to know about color scientifically. Mary understands wavelengths of light perfectly. She knows that red light has a wavelength of about 700 nanometers. She knows how the human eye processes different wavelengths. She understands how the brain interprets these signals as color experiences. She has read every scientific paper about color perception. She can explain how colors affect human emotions and behavior. She knows which colors are warm and which are cool. She understands color theory and how artists mix pigments. Despite all this knowledge, Mary has never actually experienced seeing red, blue, or yellow. She has only seen the world in shades of black, white, and gray. Everything she knows about color comes from scientific descriptions and measurements. The crucial question emerges when Mary finally leaves her room. When she sees a red apple for the first time, does she learn something new? If she gains new knowledge from this experience, then there must be something about consciousness that cannot be captured by physical facts alone. This suggests that conscious experience has qualities that exist beyond scientific description. Some philosophers argue that Mary learns nothing new. They claim her scientific knowledge already contained everything there was to know about color. The experience of seeing red is simply the same information presented in a different format. Like reading about music versus hearing music, the content remains identical even if the delivery method changes. Other philosophers insist that Mary definitely learns something new. They argue that conscious experience possesses qualities that cannot be reduced to physical processes. The redness of red, the blueness of blue, these qualities exist as irreducible features of consciousness. No amount of scientific knowledge can capture the essence of these experiences. This debate connects to larger questions about the nature of mind and reality. If Mary learns something new, then consciousness might involve non-physical properties. This could mean that our mental experiences cannot be fully explained by brain activity alone. It suggests that subjective experience represents a fundamental aspect of reality. The thought experiment challenges materialist views of consciousness. Materialists believe that everything, including consciousness, can be explained through physical processes. If Mary's experience teaches her something that scientific knowledge could not, then pure materialism might be incomplete. The experiment also raises questions about knowledge itself. We typically assume that scientific understanding represents the highest form of knowledge. But Mary's situation suggests that experiential knowledge might be fundamentally different from intellectual knowledge. Perhaps some truths can only be accessed through direct experience. Consider how this applies to other experiences. Can someone who has never felt pain truly understand what pain means? Can someone who has never felt love fully comprehend love through descriptions alone? Mary's Room suggests that conscious experiences possess irreducible qualities that resist complete scientific analysis. The thought experiment connects to modern neuroscience debates. Scientists can map brain activity associated with color perception. They can identify which neurons fire when someone sees red. But does this neural activity fully capture the experience of redness? Mary's Room suggests that something essential might be missing from purely physical descriptions. This has implications for artificial intelligence and consciousness. If machines could perfectly simulate human brain activity, would they truly experience consciousness? Or would they be like Mary before leaving the room, processing information about experiences without actually having those experiences? The experiment ultimately asks whether consciousness represents more than just information processing. It questions whether subjective experience constitutes a fundamental aspect of reality that cannot be reduced to physical descriptions. Mary's journey from knowledge to experience illustrates the mysterious gap between understanding something intellectually and experiencing it directly. The dark room problem. The dark room problem means questioning why we seek experiences and take actions instead of simply minimizing suffering by avoiding all stimulation. This philosophical puzzle challenges how we understand motivation, pleasure, and what makes life worth living. Imagine you could spend your entire existence in a perfectly dark, quiet room where nothing bad could ever happen to you. You would receive just enough nutrition to survive. You would face no physical pain, no emotional heartbreak, no disappointment, no stress, no anxiety. Every source of potential suffering would be eliminated completely. According to some philosophical theories, this situation should represent the ideal life. If avoiding pain and maximizing pleasure drives all human behavior, then the dark room offers perfect optimization. You eliminate all negative experiences while maintaining basic existence. Yet most people would find this prospect horrifying rather than appealing. The problem reveals fundamental questions about what motivates human behavior. Simple pleasure-seeking theories suggest we should prefer states with maximum pleasure and minimum pain. But the dark room scenario exposes the inadequacy of this framework. Most people would choose a life with both joy and sorrow over a life with neither. This suggests that humans value more than just pleasant sensations. We seem to desire meaning, growth, connection, and achievement even when these pursuits involve risk and potential suffering. We want to love despite the possibility of heartbreak. We want to create despite the possibility of failure. We want to explore despite the possibility of danger. The dark room problem connects to questions about consciousness and free will. If we were purely rational beings focused on maximizing pleasure and minimizing pain, we might indeed choose the dark room. Our rejection of this option suggests that human motivation involves more complex factors than simple hedonistic calculation. Consider how this applies to modern life. People often choose challenging careers, difficult relationships, and demanding hobbies. Mountain climbers risk death for experiences that involve extreme discomfort. Parents accept sleepless nights and constant worry for the joys and challenges of raising children. Artists struggle with poverty and rejection to pursue creative expression. These choices seem irrational from a simple pleasure maximization perspective. The dark room would offer more comfort and less suffering. Yet people consistently choose engagement over withdrawal, complexity over simplicity, meaning over mere pleasure. This suggests that human values extend far beyond basic comfort. The problem also challenges certain therapeutic approaches. If someone experiences depression or anxiety, should the goal be eliminating all negative emotions? Or do negative emotions serve important functions that make life more meaningful? The dark room problem suggests that complete emotional numbing might not represent true well-being. Evolutionary psychology offers one explanation for our rejection of the dark room. Our ancestors survived by exploring, creating, and building relationships despite risks. Those who remained safely hidden likely failed to reproduce successfully. We might be genetically programmed to seek engagement and challenge even when comfort would be safer. But this evolutionary explanation raises further questions. If our preferences result from evolutionary programming rather than rational choice, are they truly valid? Should we trust instincts that push us toward suffering when we could choose comfort? The dark room problem forces us to examine whether our values reflect genuine wisdom or mere biological programming. The thought experiment also connects to questions about artificial intelligence and robot consciousness. If we created machines with human-like intelligence, would they choose the equivalent of a dark room? Or would they, like humans, seek out challenge and meaning despite potential suffering? Some philosophers argue that the rejection of the dark room demonstrates the existence of objective values. Perhaps meaning, beauty, love, and growth represent genuine goods that exist independently of our preferences. Our instinctive rejection of pure comfort might reflect accurate recognition of these deeper values. Others suggest that our preferences simply reflect the particular way consciousness evolved on Earth. Different forms of consciousness might legitimately prefer different approaches to existence. The dark room problem remains unresolved because it touches on fundamental questions about the nature of value and meaning. The experiment ultimately asks whether life's meaning comes from pleasure, achievement, connection, or something else entirely. It challenges us to examine what we truly value and why we value it. Sleeping Beauty Paradox. Sleeping Beauty Paradox means confronting how probability and knowledge interact when memory becomes unreliable. This thought experiment reveals deep puzzles about what we can know and how we should reason when our access to information changes mysteriously. The experiment begins with Sleeping Beauty agreeing to participate in a strange study. On Sunday, researchers put her to sleep using a drug that will make her forget specific experiences. While she sleeps, they flip a fair coin. If the coin lands heads, they wake her up once on Monday, interview her briefly, then put her back to sleep until Wednesday when the experiment ends. If the coin lands tails, the procedure becomes more complex. They wake her up on Monday, interview her, then give her a memory-erasing drug so she forgets the Monday interview completely. They put her back to sleep, then wake her up again on Tuesday for another interview. After Tuesday's interview, they put her back to sleep until Wednesday when everything ends. The crucial question emerges during each interview. Sleeping Beauty knows the experimental setup completely. She knows about the coin flip, the memory drugs, and the different procedures for heads versus tails. But she has no way of knowing which day it is or whether she has been interviewed before. Given this situation, what should she believe about the probability that the coin landed heads? Two major answers compete for acceptance. The first approach, called the third Earth position, argues that Sleeping Beauty should assign 1/3 probability to heads. This reasoning focuses on the fact that she could be in one of three equally likely situations. She could be experiencing the Monday interview after heads, the Monday interview after tails, or the Tuesday interview after tails. Since only one of these three scenarios involves heads, the probability should be 1/3. The second approach, called the half-Earth position, argues that Sleeping Beauty should maintain her original assessment of 1/2 probability for heads. This reasoning emphasizes that the coin flip was fair, and her awakening provides no new information about the coin's outcome. The experimental setup might change how often she experiences interviews, but it does not change the fundamental fact that heads and tails were equally likely outcomes. Both positions seem reasonable, yet they reach contradictory conclusions. This creates a genuine paradox that reveals fundamental disagreements about the nature of probability and rational belief. The controversy connects to deeper questions about what probability means and how we should update our beliefs when new evidence arrives. The third position treats probability as measuring degrees of belief relative to possible experiences. From Sleeping Beauty's perspective, she finds herself in one of several possible situations, and she should distribute her credence equally among those possibilities. This approach emphasizes the subjective nature of probability as a measure of uncertainty. The half-Earth position treats probability as measuring objective features of the world that remain independent of an observer's particular experiences. The coin had a 50% chance of landing heads regardless of how many times Sleeping Beauty gets interviewed about it. This approach emphasizes probability as an objective feature of physical processes. The paradox becomes even more puzzling when we consider betting scenarios. Suppose researchers offered Sleeping Beauty a bet during each interview. Would her betting strategy depend on whether she accepts the third or half reasoning? Different approaches to probability could lead to different decisions about when to accept bets and how much to wager. The thought experiment connects to questions about personal identity and continuity of self. Is the person being interviewed on Monday the same as the person being interviewed on Tuesday? The memory-erasing drugs create discontinuities in experience that complicate normal assumptions about identity and knowledge. Consider how this applies to real-world situations involving memory, identity, and probability. People with certain medical conditions experience memory loss that creates similar uncertainties about their experiences and knowledge. How should they reason about probabilities when their access to information becomes unreliable? The paradox also raises questions about the foundations of probability theory itself. Different approaches to interpreting probability lead to different answers about what Sleeping Beauty should believe. This suggests that our understanding of probability and rational belief might need refinement or revision. Some philosophers propose compromise positions that attempt to resolve the paradox by distinguishing between different types of probability or different contexts for belief formation. Others argue that the paradox reveals fundamental inconsistencies in how we think about probability and that one of the competing positions must be abandoned entirely. Quantum immortality. Quantum immortality means exploring whether consciousness might persist indefinitely through the strange mechanics of quantum physics. This thought experiment pushes the boundaries of both physics and philosophy, asking whether death might be impossible from the perspective of conscious experience. The concept builds upon quantum mechanics' most puzzling feature known as superposition. According to quantum theory, particles can exist in multiple states simultaneously until someone observes them. The famous thought experiment involving Schrödinger's cat illustrates this principle. A cat in a sealed box connected to a quantum device remains both alive and dead until someone opens the box to check. The many worlds interpretation of quantum mechanics suggests that all possible outcomes of quantum events actually occur, but in separate parallel universes. When you observe the cat, you do not determine its state. Instead, you discover which universe you inhabit. In one universe, you find a living cat. In another universe, you find a dead cat. Both outcomes happen, but conscious observers experience only one branch of reality. Quantum immortality extends this reasoning to human consciousness and death. Consider a scenario where your survival depends on quantum events. Imagine a machine that monitors radioactive decay, a genuinely quantum process. Each second, the machine has a 50% chance of detecting decay. If it detects decay, the machine kills you instantly and painlessly. If it detects no decay, you survive for another second. After 1 second, 2 parallel universes exist. In one universe, the machine detected decay and you died. In another universe, the machine detected nothing and you survived. According to many worlds interpretation, both outcomes occur simultaneously in separate realities. But here comes the crucial insight. In the universe where you died, your consciousness no longer exists to experience anything. You can only continue experiencing reality in universes where you survived. From your subjective perspective, you will always find yourself in the universe where the machine failed to kill you. This reasoning continues indefinitely. After 1 minute, you exist only in universes where the machine failed 60 consecutive times, an outcome with probability roughly 1 in a billion. After 1 hour, you exist only in universes with astronomically improbable survival streaks. Yet from your perspective, these incredibly unlikely scenarios represent the only realities you can experience. Quantum immortality suggests that consciousness cannot experience its own termination. Every time death approaches, consciousness necessarily finds itself in whatever universe allows continued existence. Death remains possible from external perspectives, but impossible from the perspective of the dying person. This creates deeply strange implications. If quantum immortality works, you should expect to experience increasingly improbable survival scenarios as you age. You might find yourself surviving accidents that should have been fatal, diseases that should have been terminal, aging processes that should have ended your life. Each narrow escape would seem miraculous from outside perspectives but inevitable from your internal perspective. The theory raises profound questions about the nature of consciousness and identity. If multiple versions of you exist across parallel universes, which one represents the real you? When some versions die while others survive, Does your consciousness somehow transfer between universes, or does it simply continue in whatever universe permits continuation? Critics point out several problems with quantum immortality. The theory assumes consciousness depends on specific physical processes that can be preserved through quantum mechanics. But consciousness might involve classical rather than quantum processes, making the entire argument irrelevant. Additionally, survival might not always represent the best possible outcome. You might find yourself in universes where you survive but experience severe suffering or disability. The thought experiment also raises questions about probability and subjective experience. Even if quantum immortality works, should you expect to experience increasingly improbable survival scenarios? The mathematical reasoning behind these expectations involves complex assumptions about how consciousness relates to probability across multiple universes. Consider how this connects to questions about suicide and risk-taking behavior. If quantum immortality works, attempting suicide might simply ensure that you experience failed suicide attempts with increasingly severe consequences. Taking dangerous risks might lead to survival in universes with permanent injuries or disabilities. Some interpretations suggest that quantum immortality might not prevent aging or deterioration, only death itself. This could lead to the horrifying prospect of consciousness trapped in increasingly decrepit bodies that somehow never quite die, experiencing eternal suffering without the release of death. The concept ultimately challenges basic assumptions about mortality, consciousness, and the nature of existence itself. It suggests that death might represent a fundamentally different phenomenon than commonly understood. Last Thursdayism. Last Thursdayism means confronting the unsettling possibility that all of reality, including our memories and evidence of the past, came into existence just moments ago. This thought experiment challenges our most basic assumptions about time, memory, and what we can truly know about the world around us. The concept suggests that the entire universe was created last Thursday with all physical evidence of a longer history already in place. Every fossil, every light from distant stars, every historical document, every memory in your brain, all of it appeared simultaneously as part of a fully formed reality with an apparent but illusory past. When you remember your childhood, those memories feel completely real and authentic. You can recall specific moments, emotions, and experiences with vivid detail. But according to Last Thursdayism, these memories never corresponded to actual events. They were simply installed in your brain when you were created last Thursday, along with all the neural pathways that make them feel genuine. The same applies to all physical evidence of history. Archaeologists study ancient artifacts that seem millions of years old. But these objects were created last Thursday with all the signs of aging already present. The layers of sediment, the carbon dating, the wear patterns, everything was manufactured to create the appearance of great antiquity. Even more disturbing, your relationships with other people might be based on shared false memories. When you and your friend reminisce about experiences you supposedly had together, both of your brains contain matching but fabricated memories of events that never occurred. Your entire sense of personal identity rests on a foundation of implanted experiences. The thought experiment reveals a fundamental problem with empirical knowledge. We typically trust our senses and memories to tell us about reality. We believe that physical evidence provides reliable information about the past. But Last Thursdayism shows that all of this evidence could be consistent with a completely different reality than what we assume. This connects to classical philosophical skepticism about knowledge. René Descartes worried that an evil demon might be deceiving us about reality. Last Thursdayism presents a similar challenge but focuses specifically on temporal deception. Instead of doubting whether external objects exist, we doubt whether the past actually happened. The scenario seems logically possible even if wildly improbable. Nothing in our current experience would change if Last Thursdayism were true. The world would look, feel, and behave exactly as it does now. Our scientific theories would still work perfectly for making predictions. Our relationships would still feel meaningful. Our memories would still seem authentic. But the implications would be staggering. Every historian would be studying fictional events. Every photo in your album would document moments that never occurred. Every story about human progress, every account of personal growth, every narrative about cause and effect would be based on illusions. Consider how this affects our understanding of causation. We typically believe that past events cause present conditions. Your education caused your current knowledge. Historical events caused current political situations. But if last Thursdayism is true, then nothing actually caused the present situation except the initial creative act that brought everything into existence simultaneously. The thought experiment also raises questions about personal responsibility and moral reasoning. If your memories of past actions are false, can you be held accountable for things you apparently did but that never actually happened? Do promises made based on fabricated shared experiences carry moral weight? Some philosophers argue that last Thursdayism should not concern us because it makes no practical difference to our lives. Whether the past actually happened or was fabricated, we must navigate reality using the same evidence and reasoning. Our scientific methods, moral principles, and personal relationships function identically in either scenario. Others find this dismissal unsatisfactory. Truth matters independently of practical consequences. If last Thursdayism were accurate, then most of our beliefs about reality would be fundamentally mistaken. The fact that these mistakes do not interfere with daily life does not make them less significant philosophically. The scenario connects to modern physics and cosmology. Some scientific theories suggest that the universe might have properties that resemble last Thursdayism. For example, certain models of cosmic inflation could produce regions of spacetime with apparent histories that never actually unfolded. The thought experiment also relates to questions about computer simulations and virtual reality. If we were living in a sophisticated simulation, our programmed memories and simulated physical evidence might be indistinguishable from those in a last Thursday universe. Both scenarios involve realities with fabricated pasts that feel completely authentic to their inhabitants. Religious and theological implications emerge as well. Some creation stories describe gods creating the world with apparent age and history. Last Thursdayism pushes this concept to an extreme, suggesting that even recent history might be fabricated rather than genuine. The experiment ultimately asks whether we can know anything certain about the past or whether we must accept that all historical knowledge rests on unprovable assumptions about the reliability of evidence and memory. Boltzmann brains. Boltzmann brains means grappling with the possibility that conscious observers like ourselves might be random quantum fluctuations rather than products of biological evolution. This thought experiment emerges from physics and challenges our understanding of consciousness, probability, and cosmic history. The concept begins with Ludwig Boltzmann's insights about thermodynamics and entropy. According to the second law of thermodynamics, isolated systems tend toward maximum entropy or disorder. But Boltzmann realized that random thermal fluctuations could occasionally decrease entropy locally, creating temporary pockets of order within overall chaos. In principle, these fluctuations could produce any configuration of matter, no matter how complex or unlikely. Given enough time and space, random movements of particles could spontaneously form a functioning brain complete with memories, thoughts, and conscious experiences. Such a brain would exist briefly before dissolving back into chaos, but during its short existence, it would experience genuine consciousness. Now consider the implications for our universe. If space is infinite or if the universe exists for an infinite duration, then Boltzmann brains become not just possible but inevitable. Random fluctuations would occasionally produce conscious observers with apparent memories of entire lifetimes, complete with detailed knowledge about physics, history, and personal experiences. The disturbing possibility emerges that you might be such a Boltzmann brain. Your memories of growing up, learning, and experiencing life might be false implants created by a random quantum fluctuation. Your current conscious experience might represent the brief moment of existence before your randomly assembled brain dissolves back into cosmic chaos. This scenario seems wildly improbable, but probability calculations suggest otherwise. Creating a single conscious brain through random fluctuation requires far less organization than creating an entire universe capable of supporting biological evolution. If both possibilities exist, Boltzmann brains should vastly outnumber evolved brains like the ones we assume ourselves to possess. The mathematics become even more troubling when extended to cosmological timescales. In an eternally expanding universe, the number of possible Boltzmann brains approaches infinity, while the number of evolved biological brains remains finite. This suggests that the vast majority of conscious observers should be Boltzmann brains rather than evolved creatures. If this reasoning is correct, then you should assign higher probability to being a Boltzmann brain than to being a product of biological evolution. Your apparent memories of Earth, human history, and scientific knowledge would all be random fabrications rather than genuine experiences or learning. The thought experiment creates what philosophers call a self-refutation problem. The scientific theories that predict the existence of Boltzmann brains also suggest that these theories themselves might be products of random brain fluctuations rather than genuine scientific discovery. If you are a Boltzmann brain, then your knowledge of physics might be entirely fictional. This leads to a paradox about knowledge and evidence. The same cosmological models that make Boltzmann brains probable also undermine confidence in the reliability of those models. How can we trust scientific theories if the scientists developing them might be random quantum fluctuations with fabricated memories of doing research? Some physicists propose solutions that avoid the Boltzmann brain problem. Perhaps the universe had a finite beginning that prevents infinite time for random fluctuations. Perhaps cosmic expansion or other physical processes prevent the conditions necessary for Boltzmann brain formation. Perhaps consciousness requires more than just random neural activity. Other approaches suggest that we should use the Boltzmann brain hypothesis as a criterion for evaluating cosmological theories. Models that predict too many Boltzmann brains might be rejected as inconsistent with our observed existence as apparently evolved beings. This treats our non-Boltzmann brain nature as a fundamental constraint on acceptable physical theories. The thought experiment connects to broader questions about consciousness and identity. What exactly makes a brain conscious? Could a randomly assembled collection of neurons produce genuine subjective experience, or does consciousness require more complex organization? How would we distinguish between real consciousness and a Boltzmann brain's brief moment of apparent consciousness? Consider the implications for artificial intelligence and computer consciousness. If random quantum fluctuations can produce conscious brains, then perhaps consciousness is more fundamental and widespread than typically assumed. This might support views that see consciousness as a basic feature of information processing rather than a special property of biological systems. The paradox also raises questions about the nature of scientific knowledge itself. Science assumes that our observations and reasoning provide reliable information about reality. But the Boltzmann brain hypothesis suggests that our observations might be completely unreliable fabrications. This challenges the entire epistemological foundation of scientific inquiry. Some philosophers argue that the Boltzmann brain problem demonstrates the limits of pure probability-based reasoning about consciousness and existence. Perhaps we need additional principles beyond mathematical probability to understand the nature of conscious observers and their relationship to physical reality. The thought experiment ultimately forces us to confront uncomfortable questions about the reliability of our own experiences and the nature of conscious existence in a universe governed by statistical mechanics and quantum uncertainty. Eternal return. Eternal return means contemplating the possibility that this exact moment, your current thoughts, and every detail of existence will repeat infinitely across time. This profound thought experiment challenges our understanding of meaning, mortality, and what makes life worth living when faced with endless repetition. Friedrich Nietzsche popularized this concept by asking us to imagine a demon appearing with startling news. Every moment you have ever experienced will happen again in precisely the same way. Every joy, every sorrow, every mundane Tuesday afternoon, every moment of boredom, every instant of ecstasy, all of it will repeat exactly as before, infinite times throughout eternity. The demon's message means that your current reading of these words has already happened countless times before and will happen countless times again. The specific thoughts flowing through your mind right now, the way light falls across this page, your physical posture, the sounds around you, everything repeats in perfect detail across infinite cycles of existence. This repetition includes not just major life events but every microscopic detail. The number of breaths you take today, the exact words you speak, the precise timing of every heartbeat, all of it follows an identical pattern through endless iterations. You make the same choices, have the same conversations, experience the same emotions at exactly the same moments across infinite repetitions. The thought experiment forces us to confront how we would feel about our lives if we knew they would repeat endlessly without variation. Would this knowledge fill you with joy or despair? Would you embrace your existence knowing that every beautiful moment returns infinitely? Or would you feel trapped in an eternal prison of predetermined repetition? Nietzsche suggested that accepting eternal return represents the ultimate test of life affirmation. If you could genuinely embrace the idea that your entire existence will repeat exactly as it happened, then you have achieved a profound acceptance of reality. You would need to love your life so completely that infinite repetition seems like a blessing rather than a curse. But the concept raises troubling questions about free will and personal responsibility. If everything repeats exactly as before, do you actually make choices, or do you simply follow a predetermined script? When you decide what to eat for breakfast or choose how to respond to a friend's question, are these genuine decisions or merely the playing out of an eternal pattern? The thought experiment also challenges conventional notions of progress and meaning. We typically find purpose in the idea that our actions matter, that we can learn from mistakes, that humanity advances over time. But eternal return suggests that nothing actually changes. Every mistake gets repeated infinitely. Every lesson learned gets forgotten and relearned endlessly. Consider how this affects moral reasoning. If a person commits a terrible crime, that crime gets repeated infinitely across eternal cycles. But the person also experiences infinite repetitions of any guilt, punishment, or redemption. Does infinite repetition make moral actions more significant because they echo through eternity, or less significant because they change nothing fundamentally? The concept connects to modern physics and cosmological theories. Some models of the universe suggest that spacetime might be cyclical, with the entire cosmos repeating similar patterns over vast time scales. While these cycles might not involve exact repetition of every detail, they raise related questions about the ultimate fate of existence and consciousness. Eternal return also relates to questions about personal identity across time. If your life repeats exactly, are the repeated versions genuinely you, or are they merely identical copies? What makes the you reading these words now more real than the countless previous versions who read identical words in identical circumstances? The thought experiment challenges us to examine what we truly value about existence. Many people find meaning in the uniqueness of moments, the irreversibility of time, the sense that each experience happens only once. Eternal return eliminates all of these sources of meaning, forcing us to find value in pure existence itself rather than in novelty or progress. Some interpretations suggest that eternal return might not involve conscious memory of previous cycles. You would repeat your life exactly, but without awareness of the repetition. This creates questions about whether unconscious repetition differs philosophically from conscious repetition. Does it matter if you remember living this moment before? The concept also raises questions about the nature of time itself. Eternal return seems to require a very specific understanding of temporal reality where identical moments can occur multiple times. This challenges linear conceptions of time and raises complex metaphysical questions about the relationship between time and existence. Religious and spiritual traditions offer various perspectives on cyclical existence. Some Eastern philosophies describe cycles of reincarnation or cosmic repetition. But these typically involve variation and potential for spiritual progress, while Nietzschean eternal return involves exact repetition without change or development. The thought experiment ultimately asks whether we can find meaning and value in existence itself, independent of progress, novelty, or the uniqueness of temporal experience. It challenges us to love reality so completely that infinite repetition becomes acceptable or even desirable. Doppelganger universe. Doppelganger universe means accepting that somewhere in the vastness of space, an identical copy of you exists, living an identical life in an identical world. This thought experiment explores the implications of infinite space and the strange consequences of cosmic probability for personal identity and uniqueness. The concept emerges from cosmological theories about the structure of space and the distribution of matter. If space extends infinitely in all directions and contains a finite amount of matter per unit volume, then the possible arrangements of particles become limited. With infinite space but finite possible configurations, identical arrangements must eventually repeat. Consider the probability of finding another planet exactly like Earth. The chance seems astronomically small, requiring precise conditions for size, composition, distance from a suitable star, atmospheric development, and countless other factors. But in infinite space, even astronomically improbable events become certainties given unlimited opportunities for occurrence. The same reasoning applies to biological evolution and human development. The precise sequence of mutations, environmental pressures, and random events that produced human consciousness seems incredibly unlikely. But infinity makes the impossible inevitable. Somewhere in the cosmos, identical evolutionary processes unfolded on identical planets, producing identical species and identical individuals. This means that an exact copy of you exists somewhere in space. Not just someone similar to you, but someone atomically identical in every respect. This doppelganger has identical DNA, identical brain structure, identical memories, and identical thoughts. At this very moment, your cosmic twin is reading these identical words with identical comprehension and identical reactions. The distance to your nearest identical copy depends on the specific assumptions about cosmic density and structure. Some calculations suggest that your doppelganger might exist beyond the observable universe, roughly 10 to the power of 10 to the power of 29 meters away. Others propose closer distances if certain cosmological models prove accurate. But the strangeness extends far beyond single copies. Infinite space implies infinite identical copies of you, each living identical lives in identical worlds. Right now, countless versions of yourself are experiencing this exact moment with perfect synchronization. Every decision you make gets made identically by infinite other versions simultaneously. This raises profound questions about personal identity and what makes you unique. If multiple identical copies exist, which one represents the real you? Each copy has equal claim to being genuine, complete with identical memories of being the original. From each copy's perspective, the others are duplicates, but no objective standard determines authenticity. The thought experiment challenges our sense of specialness and individuality. We typically assume that our particular combination of experiences, thoughts, and personality traits makes us unique individuals. But the doppelganger universe suggests that uniqueness is illusory. Everything about you, including your sense of being special, gets replicated exactly across infinite cosmic copies. Consider how this affects decision-making and moral responsibility. When you choose between different options, infinite identical copies make identical choices simultaneously. Your decision lacks uniqueness or special significance. Yet each copy experiences the choice as genuinely personal and meaningful. The concept also raises questions about the value of personal achievement and relationships. If infinite copies of you accomplish identical achievements, do those accomplishments retain their meaning? If infinite copies experience identical love relationships, does your particular relationship remain special? Some interpretations suggest that slight variations might exist between different copies due to quantum uncertainty or chaotic systems. Perhaps your doppelgangers live nearly identical but not perfectly identical lives. This could preserve some sense of individuality while maintaining the broader concept of cosmic repetition. The thought experiment connects to questions about the nature of consciousness and subjective experience. Do all identical copies share the same consciousness, or does each possess separate but identical conscious experience? If consciousness is truly identical across copies, it becomes unclear what distinguishes different instances of the same person. Religious and philosophical implications emerge around concepts of soul and spiritual identity. Traditional notions of unique souls or spiritual essences become problematic if identical physical copies exist with identical personalities and memories. How would spiritual frameworks accommodate infinite identical copies of each person? The doppelganger universe also relates to questions about free will and determinism. If your choices get replicated exactly by identical copies, this might suggest that your decisions result from deterministic processes rather than genuine free will. Alternatively, it might indicate that free will operates identically when faced with identical circumstances. Consider the implications for human relationships and social meaning. Every conversation you have gets repeated identically by your cosmic copies. Every act of love, friendship, or creativity occurs simultaneously across infinite identical worlds. This could make relationships seem less meaningful or more meaningful, depending on your perspective. The concept challenges us to find value and meaning in existence even when uniqueness disappears. If everything about your life gets repeated exactly across infinite copies, what makes your particular instance of that life worth living? The doppelganger universe forces us to locate meaning in experience itself rather than in the uniqueness of that experience. Split brain dilemma. Split brain dilemma means confronting the unsettling possibility that consciousness might not be unified when the brain's two hemispheres cannot communicate normally. This thought experiment emerges from real medical cases and challenges our basic assumptions about the nature of self and conscious experience. The human brain consists of two hemispheres connected by a bundle of nerve fibers called the corpus callosum. This connection allows the left and right sides of the brain to share information constantly. But sometimes surgeons must cut this connection to treat severe epilepsy, creating what scientists call split-brain patients. Studies of these patients reveal disturbing insights about consciousness and identity. The left hemisphere typically controls language and logical reasoning, while the right hemisphere handles spatial processing and emotional responses. When the connection between them gets severed, each hemisphere appears to develop independent streams of consciousness. Researchers can present information to only one hemisphere by carefully controlling what each eye sees. When they show a word to the right hemisphere alone, the patient cannot say what they saw because the language-controlling left hemisphere never received that information. But the right hemisphere clearly processed the word because the patient can draw it or point to related objects. Even stranger, the two hemispheres sometimes disagree about decisions and actions. One hemisphere might try to button a shirt while the other attempts to unbutton it. One side might reach for an object while the other pushes it away. The person experiences internal conflict as their brain hemispheres pursue different goals simultaneously. This creates profound questions about personal identity and the unity of consciousness. If each hemisphere can develop independent awareness, which one represents the real person? Do split-brain patients possess two separate consciousnesses sharing one body, or does consciousness somehow remain unified despite the physical disconnection? The dilemma becomes even more complex when considering long-term adaptation. Over time, split-brain patients often develop coping strategies that minimize conflicts between hemispheres. But does this represent genuine reunification of consciousness, or simply better coordination between two separate awareness streams? Consider the implications for normal brains with intact connections. Perhaps what we experience as unified consciousness actually consists of multiple parallel processes that usually coordinate so seamlessly we never notice the underlying complexity. The split-brain dilemma suggests that our sense of being a single, unified self might be an illusion created by effective communication between brain regions. The thought experiment raises questions about moral responsibility and legal accountability. If a split-brain patient commits a crime, which hemisphere bears responsibility? Can we hold someone accountable for actions initiated by brain regions that operate independently of their verbal, reasoning consciousness? Some philosophers argue that split-brain cases demonstrate the falsity of our intuitive beliefs about consciousness. Instead of being an indivisible, unified phenomenon, consciousness might consist of multiple components that can operate separately under certain conditions. This challenges traditional notions of personal identity and individual responsibility. Others maintain that consciousness remains fundamentally unified even in split-brain cases. They suggest that the apparent independence of hemispheres represents temporary disruption rather than genuine division of consciousness. According to this view, the underlying unity of self persists despite communication breakdowns between brain regions. The dilemma connects to broader questions about the relationship between brain and mind. If cutting physical connections can divide consciousness, this supports materialist theories that treat mental phenomena as products of neural activity. But it also raises questions about how physical processes give rise to subjective experience. Consider how this applies to artificial intelligence and computer consciousness. If machines develop consciousness, could that consciousness be divided by disrupting communication between processing units? Would artificial minds face similar risks of internal fragmentation and conflict? The split-brain dilemma also relates to everyday experiences of internal conflict and indecision. When you feel torn between different desires or struggle with contradictory impulses, might this reflect the natural tendency of different brain systems to pursue incompatible goals? Religious and spiritual implications emerge around concepts of soul and spiritual unity. Traditional beliefs about indivisible souls or unified spiritual essences become problematic if consciousness can be physically divided. How would spiritual frameworks account for cases where one person appears to house multiple streams of awareness? The thought experiment ultimately challenges us to examine what we mean by self, consciousness, and personal identity. It forces us to consider whether our sense of being unified individuals reflects genuine metaphysical truth or merely the successful coordination of multiple underlying processes. The hallucinatory reality. The hallucinatory reality means questioning whether we can ever distinguish between genuine perception and convincing hallucination when both experiences feel equally real to consciousness. This thought experiment explores the fundamental unreliability of sensory experience and challenges our confidence in distinguishing reality from illusion. Imagine that advanced technology could stimulate your brain directly, creating sensory experiences indistinguishable from genuine perception. These artificial experiences would feel completely authentic. You would see colors, hear sounds, feel textures, and smell odors with perfect clarity and detail. Your brain would process these synthetic sensations exactly as it processes real sensory input. Now consider that you might already be experiencing such artificial stimulation without knowing it. Perhaps sophisticated machines are feeding signals directly into your nervous system right now. The room around you, the words you are reading, the sensations in your body, all of it could be elaborate hallucinations produced by external manipulation of your brain. This possibility seems disturbing because hallucinations and genuine perceptions feel identical from the inside. When someone hallucinates, their experience possesses the same subjective reality as authentic perception. They see, hear, and feel things with complete conviction. The hallucination does not announce itself as false or artificial. The thought experiment reveals a fundamental problem with trusting sensory experience. We typically assume that our senses provide reliable information about the external world. But if artificial stimulation can produce identical experiences, then sensory data alone cannot distinguish between reality and illusion. Every moment of apparent perception could theoretically be hallucination. This connects to classical philosophical skepticism about knowledge and reality. René Descartes worried that an evil demon might be deceiving us about the external world. The hallucinatory reality updates this concern with modern neuroscience, suggesting that technological rather than supernatural deception could fool our senses completely. Consider how this affects scientific knowledge and empirical investigation. Science relies on observation and measurement to understand reality. But if our observations could be sophisticated hallucinations, then the entire scientific enterprise becomes questionable. How can we trust experimental results if our perceptions might be artificially generated? The thought experiment also raises questions about the nature of consciousness and subjective experience. If artificial brain stimulation can create experiences identical to genuine perception, this suggests that consciousness depends entirely on patterns of neural activity rather than on actual contact with external objects. Your experience of reality might be nothing more than electrical and chemical events in your brain. Some interpretations of the hallucinatory reality lead to solipsism, the view that only your own mind exists with certainty. If external reality might be entirely hallucinatory, then perhaps only your conscious experience represents genuine existence. Everything else, including other people and physical objects, could be products of artificial stimulation. But the thought experiment creates practical paradoxes about how to live with radical uncertainty about reality. Even if your experiences might be hallucinations, you must still navigate them as if they were real. You cannot simply ignore apparent dangers or opportunities because they might be artificial. The possibility of hallucination does not eliminate the need to respond appropriately to experienced situations. Consider how this applies to mental health and psychiatric conditions. People experiencing hallucinations face the practical challenge of distinguishing between genuine perceptions and false ones. The hallucinatory reality suggests that this distinction might be impossible in principle rather than merely difficult in practice. The concept also relates to virtual reality and immersive technologies. As artificial environments become more sophisticated, the line between real and simulated experience continues to blur. Eventually, virtual realities might become indistinguishable from authentic reality, making the hallucinatory reality scenario technologically feasible. Some philosophers argue that the possibility of hallucinatory reality should not concern us because it makes no practical difference to our lives. Whether our experiences are real or artificial, we must respond to them using the same reasoning and decision-making processes. The functional identity of real and hallucinatory experiences eliminates any meaningful distinction between them. Others find this dismissal unsatisfactory because truth matters independently of practical consequences. If our entire experienced reality consists of elaborate hallucinations, then most of our beliefs about the world are fundamentally mistaken. The practical similarity of real and artificial experiences does not eliminate the philosophical significance of the distinction. The thought experiment also raises questions about personal relationships and emotional connections. If other people might be hallucinatory projections rather than genuine individuals, do relationships with them carry the same moral weight? Can love and friendship remain meaningful when their objects might be artificial constructs? Religious and spiritual implications emerge around questions of divine reality and transcendent truth. If physical reality might be hallucinatory, perhaps spiritual or religious experiences represent more reliable access to genuine truth. Alternatively, spiritual experiences might be equally susceptible to artificial manipulation. The hallucinatory reality ultimately forces us to confront the limits of empirical knowledge and the fundamental uncertainty that accompanies conscious experience in any reality where sophisticated deception becomes possible. Plank of Carneades. Plank of Carneades means examining whether survival instincts can justify actions that would normally be considered morally wrong when faced with life-or-death situations. This ancient thought experiment explores the tension between moral principles and practical necessity when extreme circumstances force impossible choices. The scenario begins with a shipwreck in rough seas. Two sailors find themselves struggling in the water as their vessel sinks beneath the waves. In the chaos, they spot a single wooden plank floating nearby. The plank can support only one person's weight. If both sailors try to use it simultaneously, the plank will sink and both will drown. If one sailor claims the plank exclusively, that person will survive while the other dies. Both sailors have equal right to life and equal claim to the plank as survivors of the same disaster. Neither person bears responsibility for creating this desperate situation. Both possess the same fundamental human dignity and moral worth. Yet the physical reality of the situation means that only one can survive. The crucial question emerges when one sailor reaches the plank first but the second sailor attempts to climb on as well. Would the first sailor be morally justified in pushing the second away, knowing this action will cause death? Does the right to self-preservation override the obligation not to harm others? Some argue that extreme necessity creates moral exceptions to normal ethical rules. When faced with unavoidable death, people have the right to take whatever actions ensure their survival, even if those actions would be wrong under ordinary circumstances. The instinct for self-preservation represents such a fundamental drive that moral principles cannot reasonably demand its suppression. This perspective suggests that moral obligations have limits based on what we can reasonably expect from human beings. Asking someone to sacrifice their life for abstract moral principles when survival is possible might exceed the bounds of reasonable moral demand. The survival situation creates circumstances where normal moral rules become suspended. Others maintain that moral principles remain binding regardless of circumstances. Taking actions that directly cause another person's death cannot be justified even when facing death yourself. The moral prohibition against killing others applies especially strongly when the victim is innocent of any wrongdoing and has equal right to the life-saving resource. According to this view, if neither person has superior claim to the plank, then neither has the right to exclude the other through force. The morally correct choice might be to share the plank even if this means both people die, rather than allow one person to survive through causing another's death. The thought experiment becomes more complex when we consider different variations of the scenario. What if one sailor is stronger and better able to survive in the water without the plank? What if one sailor has dependents who need their survival while the other has none? What if one sailor contributed more to the ship's operation or paid more for passage? The plank scenario also connects to broader questions about the foundations of moral obligation. Some ethical theories ground morality in consequences and might support whichever action produces the best overall outcome. Others ground morality in duties and rights that remain binding regardless of consequences. Consider how this applies to modern emergency situations and resource allocation decisions. When hospitals have limited life-saving equipment, medical personnel must decide who receives treatment first. When rescue teams can save only some people from disasters, they must choose who to prioritize. These real-world situations mirror the essential structure of the Planck dilemma. Legal systems also grapple with similar questions about necessity defenses and emergency exceptions to normal rules. Courts sometimes excuse actions that would ordinarily be criminal when those actions were necessary to prevent greater harm or save life. But legal necessity defenses typically require that the harm prevented exceed the harm caused. The thought experiment raises questions about the relationship between moral reasoning and emotional response. In actual life or death situations, people often act on instinct rather than careful moral deliberation. Should moral evaluation focus on what people actually do under extreme stress, or on what they would choose after calm reflection? Religious and cultural traditions offer varying perspectives on sacrifice, self-preservation, and moral obligation in extreme circumstances. Some emphasize the supreme value of preserving life, while others stress the importance of moral purity even unto death. The plank of Carneades ultimately challenges us to examine what we believe about the absolute nature of moral principles and whether ethics must accommodate the practical limits of human psychology and physical reality. Buridan's donkey. Buridan's donkey means exploring what happens when rational decision-making breaks down because available choices appear perfectly equal in value. This medieval thought experiment challenges our understanding of free will, rational choice, and how decisions get made when reason alone provides no guidance for action. The scenario involves a donkey placed exactly halfway between two identical piles of hay. Both piles are the same size, quality, and distance from the donkey. The donkey is equally hungry and equally attracted to both options. From any rational perspective, the two piles of hay present identical value and desirability. According to strict rational choice theory, the donkey cannot prefer one pile over the other because no objective reason supports choosing either option. Both choices offer identical benefits and costs. Any preference would be arbitrary rather than rational. Yet the donkey needs food to survive and must eventually choose one pile or starve. The thought experiment suggests that pure rationality alone might be insufficient for making decisions. If reason cannot distinguish between equally valuable options, then some additional factor must determine choice. This could be random impulse, unconscious bias, physical positioning, or other non-rational influences. The dilemma reveals a paradox in rational decision theory. Rationality requires choosing options that maximize value or minimize cost. But when multiple options offer identical value, rational analysis provides no guidance for selection. The most rational choice might be to flip a coin or use some other arbitrary method to break the tie. This connects to broader questions about human decision-making and the role of reason in guiding behavior. People often face situations where multiple options seem equally attractive or where careful analysis fails to reveal clear preferences. How do we make choices when reason runs out of useful guidance? Some philosophers argue that the donkey scenario demonstrates the limits of pure rationality as a guide for action. Real decision-making might require intuition, emotion, or other non-rational factors to function effectively. Reason can evaluate options and identify trade-offs, but something beyond reason must ultimately determine choice. Others suggest that the scenario involves flawed assumptions about choice and preference. In real situations, perfectly identical options rarely exist. Even tiny differences in timing, positioning, or circumstance can provide rational grounds for preference. The donkey might notice that one pile sits in better sunlight or seems slightly more accessible. The thought experiment also raises questions about free will and determinism. If the donkey's choice cannot be based on rational deliberation, what determines which pile gets selected? Random physical processes, unconscious mental activity, or predetermined factors might make the choice, raising questions about whether genuine freedom exists in decision-making. Consider how this applies to modern decision situations. People choosing between similar job offers, comparable housing options, or equivalent consumer products often face Buridan's donkey scenarios. When rational analysis reveals no clear preference, additional factors like gut feeling, aesthetic appeal, or arbitrary criteria become decisive. The dilemma becomes particularly relevant in moral and ethical choice situations. When moral principles conflict or provide ambiguous guidance, people must somehow choose courses of action despite the lack of clear rational direction. How do we make ethical decisions when careful moral reasoning fails to identify preferred options? Game theory and economics address similar problems through concepts like mixed strategies and randomization. When no pure strategy dominates others, the optimal approach might involve random selection among equally good options. This mathematical solution treats arbitrary choice as rationally justified when alternatives offer identical expected value. But the donkey scenario raises deeper questions about the nature of choice itself. Does genuine choice require the ability to distinguish between options based on their merits? Or can arbitrary selection among equivalent alternatives still count as meaningful decision-making? The thought experiment also connects to questions about identity and personality. Different individuals facing identical Buridan's donkey scenarios might make different choices based on unconscious preferences, personality traits, or decision-making styles. These personal factors could provide the additional input needed to break rational ties. Some interpretations suggest that the donkey dilemma demonstrates the importance of action over perfect analysis. Rather than becoming paralyzed by indecision when facing equivalent options, the most practical approach might be to choose quickly and commit fully to the selected alternative. Modern neuroscience offers insights into how brains handle equivalent choices through studying decision-making processes at the neural level. Brain imaging reveals that even arbitrary choices involve specific patterns of neural activity, suggesting that biological processes can generate selections when conscious reasoning cannot. The philosophical implications extend to questions about moral responsibility for arbitrary choices. If someone makes decisions through essentially random processes when reason provides no guidance, can they be held fully accountable for the consequences of those choices? Buridan's donkey ultimately challenges us to examine what we believe about rationality, choice, and the sources of human decision-making when faced with fundamental uncertainty about which action to take. The experience machine. The experience machine means questioning whether pleasure and positive experiences alone make life worth living, or whether authentic reality matters independently of how good we feel. This thought experiment challenges hedonistic theories of happiness and forces us to examine what we truly value about existence. Imagine that scientists have developed a sophisticated machine that can provide any experience you desire. Once connected to this device, you would live in a virtual reality indistinguishable from normal life, except that everything would unfold exactly as you wish. You could experience being a successful artist, loving parent, world traveler, or brilliant scientist. Every moment would bring satisfaction, achievement, and joy. The machine would stimulate your brain to create experiences of friendship, love, accomplishment, and pleasure. These feelings would be genuine from your subjective perspective. You would feel truly happy, fulfilled, and content. The artificial experiences would seem completely real and meaningful while you lived them. But the catch is that none of these experiences would actually be happening. Your apparent friends would be computer simulations. Your seeming achievements would be fictional. Your perceived contributions to the world would be imaginary. You would be living a dream of success and happiness while your actual body remained connected to the machine. The question becomes whether you would choose to plug into the experience machine permanently. Most people instinctively resist this option despite its promise of guaranteed happiness and pleasure. This resistance suggests that we value more than just positive subjective experiences, even when those experiences feel completely authentic. The thought experiment challenges purely hedonistic approaches to the good life. Hedonism claims that pleasure and happiness represent the ultimate human goods. If this were true, then the experience machine should seem attractive because it maximizes pleasure and eliminates suffering. Our reluctance to embrace the machine suggests that happiness alone is insufficient for human flourishing. What else might we value beyond subjective experience? Many people seem to care about actually accomplishing things rather than merely experiencing the feeling of accomplishment. We want our relationships to involve real people rather than convincing simulations. We desire to make genuine contributions to the world rather than just feel as if we are making contributions. This suggests that authenticity and reality possess independent value. Even if artificial experiences feel identical to genuine ones, something important gets lost when we disconnect from actual reality. The difference between real and simulated achievement seems to matter even when we cannot subjectively detect that difference. The machine scenario also raises questions about personal growth and character development. Real life involves challenges, setbacks, and difficulties that shape our personalities and capabilities. The experience machine might eliminate these growth opportunities by providing only positive experiences. Would a person who lived only through pleasant simulations develop into a complete human being? Some philosophers argue that the experience machine overlooks the importance of autonomy and genuine choice. In real life, our achievements result from our actual decisions and efforts. The machine's programmed experiences might feel authentic, but they lack the element of genuine agency that makes accomplishments meaningful. Others suggest that our resistance to the machine reflects psychological biases rather than deep philosophical truths. We might reject artificial happiness because we have evolved to value signs of fitness and survival success. But these evolved preferences might not correspond to what would actually make us better off. The thought experiment connects to modern debates about virtual reality, social media, and digital entertainment. As artificial experiences become more sophisticated and immersive, we increasingly face choices about how much of our lives to spend in simulated rather than physical reality. The experience machine pushes these choices to an extreme conclusion. Consider how this applies to psychiatric treatment and mood enhancement. Many people take medications that artificially improve their emotional states and subjective experiences. If these treatments make people feel better without changing external circumstances, do they represent steps toward the experience machine? The scenario also raises questions about what makes relationships valuable. Would relationships with artificial intelligences or sophisticated chatbots carry the same meaning as relationships with actual humans? As AI becomes more sophisticated, the line between real and artificial relationships might become increasingly blurred. Religious and spiritual perspectives often emphasize purposes and values that extend beyond individual pleasure and happiness. Many traditions teach that meaning comes from service, spiritual growth, or connection with transcendent reality. The experience machine cannot provide these goods if they require genuine rather than simulated engagement with reality. The thought experiment ultimately forces us to examine what we believe about the good life and human flourishing. It challenges us to identify what makes existence valuable beyond the simple experience of feeling good. Buridan's Bridge. Buridan's Bridge means examining the logical paradox that emerges when someone makes a promise they cannot possibly keep, creating a situation where every possible action leads to contradiction. This thought experiment explores the limits of logical consistency and the problems that arise when rigid rules encounter impossible scenarios. The scenario involves a traveler who must cross a bridge guarded by a sentinel. The sentinel announces a strange rule that governs passage across the bridge. Before crossing, each traveler must make a statement about what will happen to them. If the statement proves true, the person may cross safely. If the statement proves false, the sentinel will throw the person into the river below. Most travelers can navigate this challenge easily by making obviously true statements. Someone might say, "I will cross this bridge," and then do exactly that, making their statement true and earning safe passage. Or they might make obviously false statements, accept being thrown in the river, and swim to safety. But one clever traveler decides to test the logical limits of the sentinel's rule. This person approaches the bridge and makes the following statement: "You will throw me into the river." This creates an immediate logical paradox that breaks the entire system of bridge crossing. Consider what happens if the sentinel throws the person into the river. This action makes the traveler's statement true, because the prediction of being thrown into the river comes to pass exactly as stated. But according to the rule, people who make true statements should be allowed to cross safely, not thrown into the river. Alternatively, consider what happens if the sentinel allows safe passage across the bridge. This action makes the traveler's statement false, because the prediction of being thrown into the river does not occur. But according to the rule, people who make false statements should be thrown into the river, not allowed to cross. The sentinel faces an impossible situation where both available actions violate the established rule. Throwing the person in contradicts the rule about true statements. Allowing passage contradicts the rule about false statements. The logical system collapses because it cannot handle self-referential statements that create paradoxes. This scenario belongs to a family of logical puzzles known as semantic paradoxes, which include famous examples like the liar paradox. These paradoxes reveal fundamental problems that arise when language refers to itself in certain ways, creating statements that cannot be consistently evaluated as true or false. The bridge dilemma illustrates how rigid rule systems can break down when confronted with sufficiently clever challenges. Legal systems, computer programs, and bureaucratic procedures often contain rules that seem comprehensive until someone discovers edge cases that create contradictions or infinite loops. Consider how this applies to modern digital systems and artificial intelligence. Computer programs must handle all possible inputs according to their programming rules. But self-referential or paradoxical inputs might cause systems to crash, loop infinitely, or produce contradictory outputs. Programmers must anticipate these challenges when designing robust systems. The thought experiment also connects to questions about logic and truth in natural language. Human communication regularly involves statements that refer to themselves or create potential paradoxes. Yet people typically navigate these situations through context, common sense, and pragmatic interpretation rather than strict logical analysis. Some solutions to the bridge paradox involve rejecting the premise that every statement must be definitively true or false. Perhaps the traveler's statement exists in a third category of neither true nor false, allowing the sentinel to respond according to different criteria or simply refuse to engage with paradoxical statements. Other approaches suggest that the sentinel should recognize the logical trap and modify the rule system to handle exceptional cases. This might involve updating the bridge crossing protocol to exclude self-referential statements or adding new categories for paradoxical situations. The scenario raises questions about the relationship between logic and practical decision-making. Pure logical analysis suggests that the sentinel faces an impossible situation with no correct solution. But practical wisdom might suggest various ways to handle the paradox, such as refusing to accept obviously paradoxical statements or interpreting the rule more flexibly. Legal scholars study similar paradoxes that arise when laws encounter self-referential or contradictory situations. Courts must sometimes decide cases where strict application of rules produces absurd or impossible results, requiring judges to interpret legal principles in ways that preserve overall coherence. The bridge dilemma also illustrates the limits of formal systems and rule-based reasoning. Mathematics and logic provide powerful tools for reasoning about the world, but they can produce paradoxes when pushed to extreme limits or when dealing with self-reference. Philosophical implications emerge around questions of truth, meaning, and the foundations of rational discourse. If language can create statements that defy logical evaluation, what does this tell us about the relationship between thought, reality, and communication? The thought experiment ultimately challenges us to consider how we should respond when rigorous application of rules leads to impossible contradictions and how we can design systems that remain robust when faced with paradoxical inputs. The trolley problem. The trolley problem means confronting the moral difference between actively causing harm and passively allowing harm to occur when both choices lead to identical outcomes. This thought experiment reveals fundamental tensions in moral reasoning and challenges our intuitions about right and wrong action. The basic scenario involves a runaway trolley speeding toward 5 people tied to the tracks who will certainly be killed unless something stops the trolley. You stand next to a lever that can divert the trolley onto a side track. However, one person is tied to the side track and will be killed if you pull the lever. You must decide whether to actively divert the trolley, killing one person to save 5. Most people intuitively feel that pulling the lever represents the correct moral choice. The mathematics seem straightforward. Saving 5 lives at the cost of 1 life produces a net benefit of 4 saved lives. This utilitarian calculation suggests that the right action maximizes overall welfare by minimizing total harm. But the thought experiment becomes more complex when we consider a variation known as the bridge scenario. In this version, you stand on a bridge overlooking the trolley tracks. The runaway trolley approaches 5 people who will be killed unless stopped. Next to you stands a large person whose body weight would stop the trolley if pushed onto the tracks. Pushing this person would kill them but save the 5 people below. Most people feel strong moral revulsion at the idea of pushing the large person, even though the mathematical outcome remains identical to the lever scenario. In both cases, you can save 5 lives by causing 1 death. Yet pushing someone feels fundamentally different from pulling a lever, despite producing the same consequences. This difference in moral intuition reveals a crucial distinction between killing and letting die, or between active harm and passive allowance of harm. Many people feel that directly causing someone's death through physical action carries greater moral weight than causing death through operating a mechanical device, even when the results are identical. The thought experiment challenges purely consequentialist approaches to ethics, which judge actions solely by their outcomes. If consequences alone determine moral value, then both scenarios should receive identical moral evaluation. The fact that most people respond differently suggests that factors beyond consequences influence moral judgment. Some philosophers argue that the distinction reflects the importance of intentions and the means we use to achieve goals. Pushing someone directly uses that person as a mere instrument to save others, violating principles of human dignity and respect. Operating a lever to divert a trolley treats the single person's death as an unfortunate side effect rather than a direct means to saving the 5. Others suggest that the moral difference stems from different kinds of rights violations. Pulling a lever might violate someone's right not to be killed, but pushing someone violates additional rights related to physical assault and using their body without consent. These additional violations make the pushing scenario morally worse than the lever scenario. The trolley problem also raises questions about moral responsibility and causation. When you pull the lever, you redirect an existing threat from 5 people to 1 person. When you push someone, you create a new threat that would not have existed without your intervention. This difference in causal structure might justify different moral evaluations. Consider how these principles apply to real-world ethical dilemmas. Medical professionals sometimes face trolley-like decisions about resource allocation, treatment priorities, and experimental procedures. Military commanders might need to choose between actions that produce different distributions of casualties. Policymakers regularly make decisions that impose costs on some people to provide benefits to others. The thought experiment becomes even more complex when we add additional variables. What if the 5 people are strangers while the 1 person is your family member? What if the 5 people are elderly while the 1 person is young? What if the 5 people chose to be in danger while the 1 person is an innocent bystander? These variations reveal how context, relationships, and background circumstances influence moral reasoning. Pure mathematical calculation of lives saved versus lives lost might provide insufficient guidance for complex ethical decisions that involve competing values and principles. Legal systems also grapple with trolley-like problems when determining criminal responsibility for harmful actions versus harmful omissions. Courts typically treat active harm more severely than passive allowance of harm, even when both produce identical consequences. This legal distinction might reflect deep moral intuitions about the difference between causing and allowing. The trolley problem ultimately forces us to examine the foundations of moral judgment and the principles we use to evaluate difficult ethical choices when human welfare hangs in the balance. Counterfactual mugging. Counterfactual mugging means exploring whether rational agents should sacrifice their own interests based on hypothetical scenarios that did not actually occur. This thought experiment challenges traditional decision theory and raises questions about how we should reason when faced with unusual logical problems involving alternate realities. The scenario begins with Omega, a superintelligent being with perfect predictive abilities. Omega approaches you with an unusual proposition based on a coin flip that occurred yesterday. You do not know the outcome of that coin flip, but Omega knows both the result and what you would have chosen in various hypothetical situations. Omega explains that if the coin had landed heads, you would have been offered a fantastic opportunity to win $1 million. The catch was that you could only win this money if you would have been willing to pay $100 in the alternative scenario where the coin landed tails. In other words, your willingness to lose money in the tails scenario would have been necessary for winning money in the head scenario. Now Omega reveals that the coin actually landed tails. You face the scenario where you must decide whether to pay the $100. This payment will not benefit you in any way because the coin flip is over and you cannot change the past. However, your decision now reveals what you would have chosen yesterday, which determines whether you would have won the $1 million in the alternative head scenario. The logical structure creates a puzzle about rational decision-making. If you refuse to pay in the actual tails scenario, this reveals that you would have also refused yesterday, which means you would not have won the $1 million in the head scenario either. If you agree to pay in the actual tails scenario, this reveals that you would have agreed yesterday, which means you would have won the $1 million in the head scenario. From a purely self-interested perspective in the present moment, paying the $100 seems irrational because it provides no benefit. The coin flip already happened, the alternative scenario cannot occur, and your payment will not change anything about your actual situation. Traditional decision theory suggests you should keep your money. But consider the broader logical implications. If you are the type of person who would refuse to pay in the tails scenario, then you are also the type of person who would have missed the opportunity to win $1 million in the head scenario. Your current decision reveals something about your decision-making algorithm that would have affected yesterday's hypothetical opportunity. The thought experiment challenges causal decision theory, which evaluates choices based only on their effects in the actual world. According to this approach, your current payment cannot cause any past events or alternative scenarios, so paying provides no rational benefit. You should keep your money and accept that the hypothetical opportunity is irrelevant. Evidential decision theory offers a different perspective by focusing on what your decisions reveal about your character and decision-making patterns. If paying the $100 is evidence that you are the type of person who would have won the $1 million in the alternative scenario, then perhaps the payment makes sense as part of a broader strategy. Some philosophers argue for functional decision theory, which evaluates choices based on their logical consequences across all scenarios where similar decision-making algorithms operate. According to this view, your payment in the tails scenario logically determines what would have happened in the head scenario, making the payment worthwhile. The counterfactual mugging connects to broader questions about identity and decision-making consistency across time. Are you the same decision-maker today as yesterday, with the same preferences and reasoning patterns? If so, your current choices might provide information about past hypothetical choices and their consequences. Consider how this applies to reputation and commitment in real-world situations. Sometimes people make costly commitments or sacrifices that do not directly benefit them but signal their reliability and character to others. These actions might pay off through future opportunities that depend on demonstrated trustworthiness. The thought experiment also raises questions about moral obligations to hypothetical or counterfactual entities. Do we owe anything to versions of ourselves that might have existed in alternative scenarios? Can rational decision-making require sacrificing actual benefits for hypothetical gains that will never be realized? The scenario becomes even more complex when we consider multiple iterations or extended versions. Suppose Omega regularly conducts such experiments with various people. If you develop a reputation for paying in counterfactual mugging scenarios, this might lead to more opportunities where your principled decision-making pays off in actual rather than hypothetical ways. Some critics argue that the counterfactual mugging relies on incoherent assumptions about prediction, free will, and temporal causation. If Omega can perfectly predict your choices, then perhaps free will is illusory and the entire decision framework becomes meaningless. Alternatively, if you have genuine choice, then perfect prediction might be impossible. The thought experiment also connects to questions about pre-commitment and strategic binding. Rational agents sometimes benefit from limiting their future options or committing to strategies that might seem suboptimal in specific circumstances. The counterfactual mugging might represent a case where commitment to paying in tails scenarios enables winning in head scenarios. Game theory provides additional perspectives through concepts like mixed strategies and randomized decision-making. Perhaps the optimal approach involves probabilistic reasoning about when to pay and when to refuse, rather than developing fixed rules for all counterfactual mugging scenarios. The philosophical implications extend to questions about the nature of rationality itself. Traditional approaches focus on maximizing expected utility in actual scenarios. But the counterfactual mugging suggests that rational decision-making might need to consider logical rather than just causal consequences of choices. Artificial intelligence researchers study similar problems when designing decision-making algorithms for autonomous systems. These systems must sometimes choose actions based on complex logical relationships and hypothetical scenarios rather than simple causal analysis of immediate consequences. The counterfactual mugging ultimately challenges us to examine what we mean by rational choice and whether traditional decision theory provides adequate guidance for all possible scenarios involving prediction, commitment, and logical interdependence between actual and hypothetical situations. Kafka's toxin puzzle. Kafka's toxin puzzle means examining whether you can genuinely intend to perform an action that you know will be irrational when the time comes to act. This thought experiment explores the relationship between intention, rationality, and self-control in decision-making situations involving delayed consequences. The scenario involves an eccentric billionaire who makes you an unusual offer. The billionaire will pay you $1 million immediately if you sincerely intend to drink a toxin tomorrow at noon. The toxin will make you sick for a day but cause no permanent harm. The crucial detail is that you only need to form the genuine intention today to receive the money now. You do not actually need to drink the toxin tomorrow to keep the money. This creates a logical puzzle about the nature of intention and rational action. To receive the $1 million, you must genuinely intend to drink the toxin tomorrow. But when tomorrow arrives, you will have no reason to follow through because you already have the money and drinking the toxin will only make you sick without providing any additional benefit. The question becomes whether you can form a sincere intention to do something that you know will be irrational when the time for action arrives. Can you genuinely commit to drinking the toxin while simultaneously knowing that you will have every reason to change your mind once you receive the payment? Most people find it difficult or impossible to form the required intention under these circumstances. Knowing that drinking the toxin will serve no purpose tomorrow makes it hard to sincerely commit to the action today. The intention seems self-defeating because it depends on overlooking the future irrationality of the planned action. This reveals important insights about the psychology of intention and commitment. Genuine intentions typically involve beliefs that the intended action will serve some purpose or provide some benefit when performed. The toxin scenario eliminates this future benefit, making sincere intention psychologically difficult to maintain. Some people might try to solve the puzzle through various self-manipulation strategies. You could arrange to forget about receiving the money, hire someone to force you to drink the toxin, or use psychological techniques to maintain commitment despite rational counterarguments. But these approaches might not satisfy the requirement for genuine intention. The thought experiment connects to broader questions about weakness of will and self-control in human decision-making. People regularly form intentions to perform actions that they later find difficult to execute. Dieters intend to avoid unhealthy food, students intend to study regularly, and workers intend to exercise after work. But when the moment for action arrives, these intentions often conflict with immediate desires or situational pressures. However, the toxin puzzle differs from typical weakness of will scenarios because the future action serves absolutely no purpose once the immediate reward is received. In normal cases of failed intention, people at least recognize that following through would provide some benefit, even if they lack the willpower to act. The toxin scenario eliminates even this recognition of benefit. The puzzle also raises questions about the nature of rational commitment and pre-commitment strategies. Rational agents sometimes benefit from binding themselves to future actions that might seem suboptimal when the time comes. But these commitments typically serve broader strategic purposes that justify the temporary irrationality. Consider how this applies to reputation and trustworthiness in social and economic relationships. People sometimes make costly commitments to demonstrate their reliability, even when following through provides no direct benefit. But these actions serve the indirect purpose of building reputation capital that pays off in future interactions. Legal contracts offer another parallel, as parties sometimes agree to perform actions that might later seem disadvantageous. The legal system enforces these agreements partly because reliable enforcement mechanisms enable beneficial cooperation that would otherwise be impossible. The toxin puzzle connects to philosophical debates about free will and determinism. If you could genuinely intend to drink the toxin, this might suggest that intentions can operate independently of rational calculation. Alternatively, the difficulty of forming such intentions might demonstrate that rational considerations necessarily constrain genuine commitment. Some philosophers argue that the puzzle reveals important limits of purely rational approaches to decision-making. Perhaps human psychology requires that intentions align with perceived future benefits, making certain types of commitment impossible regardless of their present value. Others suggest that the puzzle can be solved through more sophisticated understanding of rational self-interest that extends across time. If maintaining integrity between intention and action provides psychological or social benefits, then drinking the toxin might serve rational purposes despite its immediate costs. The thought experiment also relates to questions about personal identity and temporal consistency in values and preferences. Are you obligated to honor intentions formed by your past self, even when your current self sees no benefit in following through? Kafka's toxin puzzle ultimately challenges us to examine the foundations of commitment, intention, and rational action when immediate rewards conflict with the future purposes that typically justify our planned behaviors.